the URSAE 2021. The chairperson of today's session, Mrs. Chief Rupa Singh, one of our senior colleagues. It is great pleasure welcome you, madam, to the URSAE 2021. The key actors of this symposium, the fresh graduate of Faculty of Agriculture, University of Ruhuna, you are all welcome to the symposium. I have great confidence that you will make this event a great success. I would like to welcome all HODs, professors, academics, colleagues, and ladies and gentlemen who are attending the URSAE 2021. We have made arrangement to live stream this event in YouTube. So I hope that many people around the world will join us, and it will expand the audience of the symposium. So I cordially welcome all ladies and gentlemen who touches us during these 3 days of symposium. So this is the second undergraduate research symposium organized by the Department of Agricultural Engineering, Faculty of Agriculture, University of Ruhuna. Last year, we have organized this at the Department of Agricultural Engineering, Faculty of Agriculture, University of Ruhuna. However, due to the COVID-19 pandemic situation, this time we couldn't organize physically, so we compelled to organize this event as a virtual symposium. Symposium will continue 3 consecutive days, commencing from today under 3 different themes. Today's theme is the production technology and agricultural engineering. Presentation the second day comes under the theme of emerging environmental technology. The theme of smart farming and precision agriculture will be highlighted by the presentation the third day. So all presenters in the symposium are fresh graduates who did their final year research project under the guidance of academics of the Department of Agriculture Engineering, Faculty of Agriculture, University of Ruhuna. We know that they have faced so many difficulties during research period due to COVID-19 pandemic situation in the country. However, when we look at the abstract of the proceedings, it can be clearly noticed that they have achieved a great success in their research outcome. I believe that this symposium is a great opportunity for these fresh graduates to show and discuss their research findings with the colleagues as well as the scientific community. Well, we have taken every step to the success of the event. However, on behalf of the organizing committee, please accept our sincere apologies for any inconveniences caused during the 3-day session due to unacceptable reasons. Moreover, I would like to acknowledge the dedication and hard work of the talented our organizing committee members, as well as the head of the Department of Agriculture Engineering, without whom support this event would not be a successful event. So all of us now we are anticipating the commencement of the symposium. Therefore, I do not take much of your time. So I will conclude my address welcoming you all once again and wishing you a successful and fruitful 3 days of symposium. Thank you.
Thank you very much, sir. I'm profusely elated to take this opportunity to invite Senior Professor S.D. Vanniyarachi, Dean, Faculty of Agriculture, University of Ruhuna, to address this respected gathering.
Thank you, Kirtana. Good morning to everybody. Our keynote speaker this morning, Professor Ryoso Noguchi from the Faculty of Life and Environmental Sciences of the University of Tsukuba, Japan. Head of the Department of Agricultural Engineering, Professor Jayasinghe, coordinator of this undergraduate research symposium on agriculture, engineering and environmental technology, 2021, Professor S. Vijayatunga, and my other colleagues of the Department of Agricultural Engineering, and then HODs and those who have other academic staff members who have joined from other departments, and all other colleagues, and presenters, final year graduates, fresh graduates. Only results are to be released from the Department of Agricultural Engineering, and invited guests, ladies and gentlemen. So first of all, let me thank the organizers for giving me this opportunity to address the second undergraduate research symposium organized by the Department of Agricultural Engineering. I recall attending this symposium last year physically during a break where we had less number of COVID-19 patients and issues. So country was returning to normal at that time. So we were able to hold the symposium physically at the Department of Agricultural Engineering. But anyway, for the last several months, since the beginning of this year, so we have been having many symposia virtually due to this current COVID-19 situation. Now, I'd like to comment on the theme selected by the organizers, the innovative smart agriculture towards sustainable resilient nation. I think it is a very fitting theme, considering that we are facing many challenges during this time to increase the production of agriculture. And also Sri Lanka being a small country, and we don't have that much of a land mass. So only way out of current problems are to get the technology involved in agriculture. And then currently the smart agriculture systems are getting very popular. So I think that way we can get our young graduates as well as the young farmers get interested in starting a career in agriculture, or at least becoming entrepreneurs who would produce agriculture related goods for Sri Lanka as well as for the export market. So in that way, I think it is a very fitting theme. And let me just briefly tell you about the history of undergraduate research sessions. I think we were the first faculty of University of Ruhuna to start undergraduate research sessions, and the first one was held in 1998. So since then, it has been improved tremendously. And then currently, the main undergraduate research session of the University Faculty of Agriculture is held as a session of our main international symposium on agriculture and environment. But lately, during the last 2 years, we had to conduct that undergraduate research session. Now we call it Young Graduates Forum separately because of the delays in completion of research projects and various other issues beyond the control of the students. This one is especially important, this undergraduate symposium organized by the Department of Agriculture Engineering, because they have students from our main degree program, Agriculture Resource Management and Technology, as well as the degree program coordinated by them, the BSc in Green Technology. So at most of the time, they have nearly 50, or it would go up, I think, in the coming years, more than 50, 60 students conducting their projects. But with our main undergraduate, young graduate forum, we give the opportunity only for 3 students from the department. So in that way, it is unfair on the other students who have done their research projects in the Department of Agriculture Engineering, not being able to showcase their research talents at a symposium like this. So in that way, this is extremely important, and I would like to appreciate the Department of Agriculture and Engineering in organizing this undergraduate symposium, because I think it was inevitable that we need to do something like that, considering the large number of students, relatively speaking, specializing with the Department of Agriculture and Engineering. And also, this particular group of students, they had to undergo many difficulties and challenges, because they had to conduct all their projects within the faculty, because in other times we would allow our students, or we would encourage them to go outside research institutes and other establishments to conduct their research projects. But this year, that was not to be because of the COVID-19 situation. So all of them were thrown into a situation where they had to do all the projects within the faculty, and then they were living in the faculty for many months. So they had to undergo many hardships. But in the end, I think you could be relieved that you have almost graduated from the Faculty of Agriculture with a 4-year honors degree. So in that sense, I think you have to be extremely pleased with the accomplishment. And also now here we are today having your undergraduate research sessions also. So comparatively, you are lucky to have graduated from the faculty, considering the situation or the predicament of other batches in the faculty, because we have many exams to be conducted. So there's a lot of backlog to be cleared. And
Recording
also,
in progress.
Finally, I would like to wish these presenters, all the presenters, a very productive and pleasant stay at this symposium. And this is a 3-day symposium, so that shows you the magnitude of the work they have done. This is probably the first time. I don't remember having a 3-day symposium last time. If I'm correct, I think organizing a 3-day symposium itself is a huge challenge. And then I would like to also appreciate the keynote speakers for tomorrow and day after sessions for coming to this undergraduate symposium and sharing their research experiences with us. Right. So I have joined this from home. I'm in Goa. So I'm going to, in a few minutes time, I have to head to the faculty because we started work last Friday. Not much volume of work, but today, being a Monday, I expect a lot of administrative work to be attended at the faculty. So excuse me, I may not be able to attend the whole session this morning. So I'll be here for a while. So with that, let me wish all of you a pleasant day. And thank you very much again for giving me this opportunity.
Thank you very much, sir, for your inspiring words and for enlightening our minds with new insights. I'm honored to invite Senior Professor Champa Navaratna, Editor-in-Chief of URSAE 2021, to unveil this year's proceedings.
Thank you very much, Kirtana. And it's my great pleasure to unveil the proceedings of second undergraduate research symposium in agricultural engineering and environmental technology under the theme of innovative smart agriculture towards sustainable resilient nations. Actually, this research findings will be presented on 3 days, 4th, 5th, and 6th October 2021, under the sessions of production technology and agricultural engineering, emerging environmental technologies, and smart farming and precision agriculture. I congratulate all undergraduate pass out from Department of Agriculture Engineering for their very hard and successful work they have done so far. Thank you very much.
Thank you very much, Madam, for giving us a nice brief insight of the proceedings. To commence the technical session, I would like to invite Professor S. Vijayathunga, Coordinator, URSAE 2021, to introduce the chairperson of the scientific session.
So very good morning. Now we are ready to start the session. The theme of today's session is the production technology and agricultural engineering. Session will be chaired by one of our senior colleagues in the Department of Agricultural Engineering. She has graduated in Faculty of Agriculture, University of Ruhuna, and did her postgraduate studies AIT, Thailand, on farm machineries. Her main research interests are post-harvest technology, agricultural machinery, and renewable energy. main interest area. So I would like to cordially invite Mrs. C.P. Rupasinghe to be the chair of the today's session and start the scientific presentation. Thank you.
Thank you very much, Professor Vijay Tunga. Very good morning to all. Professor Noguchi Ryoso and Dean Professor Vanyarachi, Senior Professor Vanyarachi, our Dean of the faculty, and Professor Vijay Tunga, Coordinator of the URSAE Symposium, and our head, Professor Jayasinghe, head of the Department of Agricultural Engineering, and other heads of the departments, and all senior professors and other academic staff, and all the students. Actually, they are today, they are blooming their research findings for giving their fragrance to all over the world. Therefore, this is now I have to start the technical session on production technology and agricultural engineering. And first, I have to invite kindly our today keynote speaker, Professor Noguchi Ryoso. Actually, it's my great honor and pleasure to produce keynote speaker, Professor Noguchi Ryoso this morning. First, I thank him again and again for accepting our invitation to deliver a keynote speech on session Production Technology and Agricultural Engineering, with sharing his valuable experience on agricultural environment engineering and agricultural information engineering. Sir, I apologize for sending you our invitation recently. Therefore, due to this pandemic situation, I am very sorry for taking some time for sending you this invitation and Zoom link. And then I want to give you about your expertise. Professor Noguchi Ryoso is an associate professor in Faculty of Life and Environmental Sciences, University of Tsukuba, Japan, since 2010. Prior to that, he was an associate professor in Department of Environmental Engineering, Faculty of Agriculture, Utsunomiya University, Japan. He is a member of several academic societies, such as Japanese Society of Agricultural Informatics, the Japanese Society of Agricultural Machinery and Food Engineers, the Japan Institute of Energy, and Japan Society of Energy and Resources. Professor Noguchi Ryoso is a pioneer in agricultural environmental engineering and agricultural information engineering, and engaged in research in smart technology for pesticide application, bio-based society, biomass energy, agricultural machinery and power, oil separation and recycling systems. Currently, he is developing a high-frequency power supply type water sensor for real-time measurements and control of pesticide application, and autonomous driving speed sprayer utilizing machine version. Professor Noguchi Ryoso has received many awards. In 2011, Hashimoto Award, honor of Fellow of the Japanese Society of Agricultural Information in 2018 for long-term contribution to rural sector development, and Japanese Society of Agricultural Information Contribution Award in 2019 for his outstanding achievements in research and agricultural information and academic society management and also academic activities. Honor of Japan Agricultural Engineering Society Fellow in 2021 recently for his research activities related to research on system analysis and resource recycling biomass utilization, and research on agricultural robot development and new agricultural production system by AI, artificial intelligence. Actually, sir, I want to even at the moment also we know that some of our Sri Lankan students pass out from University of Ruhuna Faculty of Agriculture. They are also under supervision of you. They are doing their PhDs. And sir, now we are ready to listen to you. Thank you.
Hello, can I hear me?
Yes,
can you hear me?
Yes, sir. Yes.
Thank you very much for a very long introduction of me. So I'm very happy and special thanks to all your member. So Miss CP Rupa Singh, the chairperson today. Okay, can I start my presentation now?
Yes, sir.
Okay, so anyway, so I'm very glad and very honored and pleasure to have invite session to very good, very excellent symposium, undergraduate research symposium on agriculture engineering and development technology. I'm also belonging to the agriculture engineering field. That is a very important role for the agriculture by using the engineering method. I think it is little different from the biology approach. Like engineering approach is more directly and to find good achievement so that any type of the projects. So today, I'd like to introduce some research project and also my how to say the review of the agriculture engineering field by using my PowerPoint. Can I share my PowerPoint now?
Yes, sir.
Is it okay?
Yes, sir.
Okay. So this is the today's title of my presentation towards a healthier environment for the human and health. Prospects for the agricultural machinery technology and the biomass filtration technology. So today I'd like to introduce some of my review and my research project. My main purpose to the many undergraduate students in University of Ruhuna interested in me and interested in my research and have how to the schedule for the studying in University of Tsukuba. So this time, my former graduate student, PhD student from Sri Lanka Aryabansha Kumarage, he introduced me as one keynote speaker of this symposium. And I have also two Sri Lankan graduate students now as a PhD student. So if you have an interest of our university, our research, please contact me if you want to enter our PhD program. So we have some scholarship for the foreigner student and also the private finance student. So it's my purpose that today is to have a good obtain a candidate of the PhD student from you. Okay. So I think the agriculture engineering, agriculture machinery development, and also the biomass utilization, it being issue, the main important things to consider is the sustainable developing goals. It's a very common keyword and very popular, but easy to explain our goals all over the world. And my opinion to the future agricultural technology and the biomass utilization should keep the balance of human health and earth health. And our health means that we have to we can keep their intergenerational ethics and also the future children. And this is a picture of Japanese history of mechanization around the 1960s and 1960s and 90s. Almost when I was a childhood, so I also saw the rice planting by hand. But recently, so all the fields, this kind of the work is disappeared. So that we introduced the many type of the agriculture machinery, not only the walking type, but also riding, and we also introduced the rice husk planters. So that in the 60s, 1960s, we have many farmers who are planting by hand. I think this posture of the rice planting is very hard for the men and women. So I saw there are many old women who are always bending their waist and cannot stand the straight. So this is the effect of the unmechanized history. However, so that we also we have a rice planting machine almost all fields, so that there are no women who are bending their waist and cannot stand the straight. So this is a very big achievement when we introduce to the agriculture machinery to our paddy rice field. And the mechanization is a very important role for the increasing the productivity of agricultural products and also decrease the drudgery, the farming in field. And this is one of the example for the large sized tractor to manage the big size of the agricultural field. So this means the agricultural machinery now up to a large size suitable for man, not women. And however, so the recently, so the autonomous agricultural machinery, the technology introduced day by day, and some of the parts of the agricultural machinery is changed to the autonomous agricultural machinery. This concept is the automatic driving and unmanned. So I imagine how to change this kind of the progress of the agricultural mechanization to the future. I think that important keywords are inclusive. Inclusive keywords included in sustainable development goals, so that all humans, all people will be involved to such kind of the achievement. So now we also have a small type garden type tractor. This is not a farmer, but also the people who want to do gardening and small farming in their field. And also this is one of the type of the table for the cultivating, easy to the wheelchair person, easy to access and farming. And this is a very small type riding tractor developed by the women group in Iseki, that is the agriculture machinery company in Japan. So they introduce some sunlight prevention curtain, and also the very small type to the seat and easy to change the shift lever. This is just developed for the women and not men, but it is a very important role for the inviting the women to the farming. And this is one of the example for the wheelchair person can alight on the big type of the machinery in United States. I think this the concept of the new type of the agricultural machinery little bit different from the old history of mechanization. Quality of life, including participation by the elderly women and people with disability, so that we have to consider this kind of the pattern for the inviting and inviting our farming. So this is just the same concept, the Olympic Games and the Paralympic Games. So I think inclusive agriculture is one of the keywords for the future agricultural technologies. However, so now we have many autonomous agriculture machinery in all the world, but very difficult to the detail of the farming at the final stage. So the last 1 mile of agriculture that present mechanization and automation, that is a very important issue for how to solve to the mechanization. We also have an autonomous vehicle in many stations, and we can easily to carry the many goods for the many parcel by using the truck car on the highway. However, there are no solution how to deliver to home at the person to person, and it's very difficult to change to the automation. This situation is very similar in the agriculture sectors, and we also mechanized in the cultivation and the tillage and the harvesting and so on, but it is similar to the highway situations. So I'd like the harvesting by hand. So because our fruit is very fragile and easy to broken. So that it is very difficult to change to the automation or the manipulation by the robotics. So we have to consider how to apply our technology to the detail of the agricultural farming. And this is one of the scenery of how to change the agricultural production field from old to now. This is the rice terrace in Asian countries. This is the field is changed to for the mechanization. And recently, so we have so many greenhouse plants like this green factory. I think that the green factory can can introduce the many technologies. It means so the easiness, automation, and environment controls. So this type of the fields easy to introduce the mechanization and the big size of the machinery, and the easiness of large size of mechanization and automation. However, so this type of the small agricultural field based on the nature, I think this is very difficult in mechanization. But I think this is one of the challenging issue is existing to the development of small and powerful small agriculture by robotics. So which scenery? So we have to keep. So that is a very important view for the mechanization. If we want to keep this kind of the scenery or we have to introduce many small type agricultural robotics and powerful tools. And that means so that I think that one of the target of our research. And also the agriculture machinery is very, very expensive. So I heard so that developing countries cannot easily to introduce the agriculture machinery or their farming. So I strongly insist so the government or international association should support for introducing the agricultural machinery to such kind of the country who want to mechanize in their fields. So sometimes, so the automobile is independent from the government, but in my opinion, so the automobile cannot survive without a road, highway. So the many budget is used for the constructing the highway and road maintenance and so on. I think that it is the same things in the agricultural sectors. So I strongly insist to the government and the international association and other funds should support for the agriculture machinery for promoting their own agriculture. And I'd like to introduce my one research topic in our laboratory, University of Tsukuba. So in Japan, so there are so many orchards, and we also produce a lot of fruits and export to the overseas. But we met the shortage of labor. So we have to save the labor supported by the agricultural robotics. And we have to also minimize the chemical and use to prevent the drift of spraying. It means the precision farming, human and environment friendly. And we also have many accidents by hitting the tree, the farmer hitting the tree by using this kind of the agricultural machinery. We call it a speed sprayer. And it's very dangerous to the running under the tree. So it means we also have to develop the autonomous vehicle of the agricultural machinery for preventing this kind of accident. So this is one of the scenery of the developing of the speed sprayer in our laboratory. We cooperate with the Mitsubishi Mahindra Agriculture Machinery Company and the Maruyama company, who are specialized in the spraying system, spraying companies. I heard some autonomous vehicle spraying under the orchard tree. I also checked the website, but there are no such kind of the big size traditional type speed sprayer, which is autonomous, the running under the tree. Because some of the cases under the tree, it is very difficult to detect the global navigation satellite system signal. So we have to consider both the GNSS signal and GNSS system sensing, and also the LiDAR sensing and the other devices, which is to identify the routing of their field map. Okay, so I'd like to change my topics from the agricultural machinery technology to the biomass utilization. Regarding the achievement of the SDGs, the creating biomass society is very important, because so that we can keep the environment and the sustainable by mainly the use of the biomasses. However, so sometimes the biomass usage is very harmful for the human and environment. So I'd like to introduce some cases in our research. This is just a project cooperate with the Indonesian government. So they have a very big, large side of field of the palm oil production, Kalimantan and Sumatra. So one PhD student who are coming from the Indonesian government now studying how to reduce the CO2 emission from the peatland. Because so the Indonesia doesn't have a much area for the enlargement of the palm oil production. So they have to use the peatland, which under the water, so many carbon is storing. So I think the Dutch in technology easily to apply to changing the groundwater level to reduce the top of the surface of the water. And after decreasing the surface, so in the peatland, so that they plant the new oil palm plantation. However, so after decreasing the groundwater level, so many CO2 is emitted. Also, the N2O is emitted from the peatland. So the international society or the other country who import the palm oil from the Malaysia and Indonesia, they request to the Malaysia and Indonesia to protect the CO2 emission from the peatland. It is very difficult, the request for their countries. But if we can consider the land swapping from the peatland to the mineral land, we can decrease such kind of CO2 emission from the peatland, and also we can create the more high productivity of the palm oil. So now we are considering how much the cost is required and how much the CO2 can be protected, this kind of the land swapping. And I also am a member of the microalgae center in University of Tsukuba. So I also had one of the I was a member of the big project of the microalgae fuel productions. And after this project, so we found the key point is how to reduce the total cost and the total CO2 emission. So one of the key point is to reduce the nutrient cost for the microalgae productions. So this is one of the idea for the microalgae production is applied to the wastewater treatment. So this like the bioremediation by the microalgae. So this is the oxidation ditch method of the wastewater treatment system. So we have many such kind of the facility in the rural area in Japan. So that after decreasing the population in the rural area, we can convert this type of the wastewater facility to the cultivation pond of the microalgae. Sometimes the microalgae is very fragile and very weak for the contamination. Now we are conducting the native algae, polyculture algae cultivation in such kind of the field. So finally, so we can reduce the total CO2 emission and produce the fuel and through the bioremediation wastewater treatment. And in this case, we have to use the CO2, waste CO2 and waste heat from the factories. And the other Indonesian students also consider how to treat, how to use the POMI, palm oil meal effluent, which is a very rich nutrient for the microalgae to cultivate. After using this POMI for the nutrient of microalgae, we can also reduce the methane emission of the POMI pond. So this is also one of the research of the bioremediation by the microalgae. And this is the one of the research in my laboratory, rice husk combustion. The taking energy, heat energy from rice husk combustion has a very long history all over the world. And the rice husk charcoal is a very good material for the soil conditioner in the paddy rice field too. However, if we keep the high temperature and the long time combustion, high temperature means over the 800 or the 900 Celsius degree, and over the 3 minutes or 5 minutes, so that the crystallized silica is occurred, tridymite and crystalline. It is one of the problem for the silicosis, for occurring the silicosis in the human lab. So if we taking high energy or from the rice husk, we have to keep the short time combustion. So the one agriculture machinery company providing this rice husk combustion burner to check how much the crystallized silica is occurred after combustion of rice husk. So this is one of my research to protect the human health problem and attain the zero risk for the human. Okay, so I'd like to move the conclusions. So I'd like to insist the important thing to the balance of the human health and earth health. So now we are using the engineering approach as a AG field, greenhouse, machine, robotics with sensors. I think the new technologies is contribute to increase the productivity of the agricultural production and also keep the environment. And the earth can provide after the manipulating and approaching by this kind of the technology, they provide the food and the biomass, and we are using and eating. However, so far until now, so the main focus is how to keep the human health. But so that we have to consider how to keep the earth health for our next generations. Okay, so this is my second conclusions. Some of the cases, mechanization in developing country is very difficult. But so this is one of the example, the history of the communication equipment. So the wireless communication without diffusion of the wire telephone is a very success story in all the world. So this is the history of the mechanization. But if the 6G, beyond the 5G, high performance energy storage and the technology and the micro devices, so we will met the new technology. If we bet the new technologies, I think the new advanced agricultural machinery will be developed. I I think also that steadily the development is very important. However, we can expect such kind of the new technologies. And I heard you have many agricultural waste in Sri Lanka. So the biomass heating energy for the absorption chiller to manage the food reservation and the system in Sri Lanka is one of the my expect the research in your countries. So my PhD student recommends to the have coconut waste and biomass use, and you have a many potential of the wind power and solar power. So if you successfully use this energy for the absorption chiller, so we can take the cool air for the cold storage in food preservation. Okay, that is my proposal, finally. Thank you very much for listening.
Thank you very much, sir. It's actually your today keynote topic on towards a healthier environment for human and earth. Actually, this is the very current topic we have to address at the moment. Without actually, we cannot anyone cannot survive without thinking the healthier environment. When we can experience it this pandemic during how we have to serve. Actually, even this is very good presentation, very good. Information for our students even. Actually, sir, you develop your keynote with facing challenges. If there are many challenges from earlier to up to now, then you explain very nicely how to address those challenges towards the new innovation. Actually, that is the way we have to think. Even our countries, our students, our actually recently passed out graduates, actually they are very close to they produce their fragrance. Therefore, it's very good opportunity for them to think about. Actually, attitudes are very important. Therefore, even they can think about how to face the challenges with new technology. Actually, sir, when I heard your presentation, a very valuable presentation, I heard that if sir we can jump from 2G to 6G, I think many problems we can resolve. Because with the internal combustion engine and invention of internal combustion engine, fuel combustion and the things, we facing many the climate issues and even global challenges. Therefore, disasters and the things. Therefore, if we can jump from 2 generations to 6 generation with using some smartphones, mobile apps, and to do the agriculture, I think actually we may have more safer environment. And also, sir, you very nicely explained about the pesticide application in how the protect the human being. Actually, ergonomics application is there because though we are doing something, but we have to, at the same time, we have to think about farmer and also environment. Therefore, nicely you explain how you develop some new technologies there. Therefore, thank you very much, sir. I give my heartiest thanks for you for delivering this very valuable keynote speech for our community to develop their attitudes and skills towards better future, better environment, better world. Thank you, sir.
Thank you very much. So I'm waiting for your recommendation of the good faculty or the graduate student to dispatch to our university. So sometimes we have an opportunity for the scholarship, but there are very short time to find a good good candidate. So if I request you, please reply quickly to the comments.
This is very golden opportunity for all of us, even our students. Actually, definitely we will work on this maybe through Dr. Aryavan, sir. Recently, sir, can you send just the time duration for having such application, calling application? We will get information from through Dr. Aryavan and also through you.
Yeah.
Yes, sir.
Yes.
Yes,
I have 2 Sri Lankan students now, so that they can explain our research activity and how to make the application documents.
Yes, we know about them, sir.
Yeah.
Thank you very much, sir.
Thank you very much.
Dear all, kindly turn on your videos to take few screenshots to keep this precious moment as a memory that lasts forever.
Okay, see you.
please kindly turn on your videos as soon as possible. Thank you very much, all. Now we can continue with the session.
Okay, thank you very much, Keerthana. Now we are going to start our presentations, technical presentations. The first research title, Design a Domestic Level Filter for Treating Kitchen Waste Water Reuse. The presentation will be conducted by TGK panel.
Good morning, everyone. Here I'm going to present our research presentation. Research topic is Design a Domestic Level Filter for Treating Kitchen Wastewater Reuse. My name is Gayara Kasuni Parnagama. This is the outline of the presentation. First, move on a brief introduction about value of water and kitchen wastewater. Why is water reuse is important? Because different domestic water usage require different water quality level. As an example, drinking and cooking require high water quality level, but water for landscaping require only low water quality level. In the present days, fresh water resources are limited, so water treatment and wastewater reuse is very important in present days. If we consider about building and home sector, there are two types of wastewater, backwater and grey water. Backwater treatment is very difficult because backwater is highly polluted and high organ content. Kitchen wastewater is classified under grey water. Grey water can be treated and reused for the irrigation purposes. But in Sri Lanka, most of the time, kitchen wastewater is thrown away. In Sri Lanka, water usage in kitchen is up to 20%. It's average 100 liters per day. Around 50 liters being used for irrigation. These are good quality water. If we reuse this kitchen water for irrigation, we can save around 1.5 cubic meter per month. Let's see what is kitchen water. Kitchen water is a type of grey water and it consists of organic material, soaps and detergents, oil and grease and other dissolved compounds. Let's move on the problem statement. There is a lot of nitrogen in food waste. Chemicals in soaps and detergent. It can be very harmful to marine and plant life because it can be providing breeding environment for insect and pests and making unpleasant odors and eutrophication. And also in the country there is a water shortage. So use this potable fresh water for landscape irrigation is a problem for the future. This research seeks to provide answer to the problem of this by providing an environmentally friendly and easy domestic treatment system. Let's move on the objectives of this study. The first objective was to characterize the raw kitchen wastewater. The second objective was to design a domestic level filter. Third objective was to evaluate the removal efficiency by newly designed filter domestic for reuse purpose. This slide shows the methodology as a summary. Let's see the methodology descriptively. Objective 1. Characterize the raw kitchen wastewater. collected the raw kitchen wastewater from the new hostel, Faculty of Agriculture, University of Ruhuna, and all the measurements were done at the Agricultural Engineering Laboratory, Faculty of Agriculture, University of Ruhuna. These are the measurements and equipments used to determine the water quality parameters. Objective 2, to design a domestic level filter for treating kitchen wastewater. There were 4 combinations in the treatment setup. This picture shows combination 1 and combination 2. All the combination systems consist in a grease trap. It was to intercept most greases and oil before kitchen wastewater entered to the treatment system. Here, combination 1 has sand and gravel layer filter unit. Combination 2 differs from combination 1 with the bricks layer unit. Gravel and bricks was in same size. The effluent was collected by this sampling tap. Then the most effective combination among combination 1 and combination 2 was selected by determining the water quality parameters results, and then a cocoa-bed filter unit was connected to the most effective combination among the combination 1 and 2. This combination is combination 3. Then activated charcoal filter unit was connected with cocoa peat for the most effective combination among the combination 1 and 2. This is the combination 4. Then data analysis part was done. One sample t-test and a pair t-test conducted by using Minitab 17 software. One sample t-test to analyze the statistical significance between raw kitchen water and reuse standard, and treated kitchen water characteristic and reuse standard, and a pair t-test was conducted to analyze the statistical significance of the removal efficiencies. Let's move the results and discussion part. This slide shows the appearance of the water. Here you can see the raw kitchen water appearance. These are the first, second, third, fourth combination effluent, final effluent water sample appearance. This table shows the average value and the range of the raw kitchen wastewater at the new hostel. This table shows the results of the t-test comparing average raw kitchen wastewater with the central environmental standards for the irrigation. Here, the t-test result shows the pH, COD and oil content p-value is greater than 0.05, which shows there was no any significant difference in the kitchen wastewater. And electrical conductivity, temperature and total dissolved solids p-value is less than 0.05. Which show the significant difference in the characteristics of kitchen wastewater. This table shows the overall results of the filter setup. You can see here, this column shows the raw kitchen wastewater characteristics. It shows the COD value is near to the 2000 milligram per liter. It is 5-fold higher than the central environmental standard tolerance values for the irrigation value. COD value is high means not only biodegradable pollutants, non-biodegradable pollutants are there. So COD removal is very important. If not, plants can hurt. This column shows the gravel and sand layer filter unit results, and this column bricks and sand. This is the third combination. This column shows the fourth combination results. Among the first and second combination, bricks and sand combination is more better than the gravel and sand combination. And also there is no significant difference in the cocoa peat. But activated charcoal there has played a major role in removing COD. You can see here in the fourth combination, the COD value was 300 and 65 milligram per liter. So, activated charcoal has played a major role in removing COD, and activated charcoal improved other water qualities too. This table shows the results of the t-test comparing average treated kitchen wastewater with the Central Environment Authority values. Here you can see, after treated, all the parameter values were significantly lower than the Central Environmental Standard for irrigation value. Therefore, t-test showed treated kitchen wastewater for final effluent in this study can be reused for irrigation purpose. This table shows the paired t-test comparing with the raw kitchen water and treated kitchen wastewater. According to the paired t-test results, all the parameters were significantly reduced by kitchen wastewater treatment setup. These are the graphs. This graph shows the pH. The graph clearly shows the raw kitchen wastewater is not under the range of the central environmental values, but with the treatment, you can see here, after the filtration, it has met the range of the pH value of central environmental values for the irrigation. This is the electrical conductivity graph. It is already under the CEA standards, and this is temperature graph. Temperature is the room temperature. It is not changed, and total dissolved solids also already under the CEA standards. This graph shows the COD values. You can clearly see here, in raw kitchen wastewater, COD value is near to the 2000. But with the treatment, the COD value met the central environmental standard value. Here, the oil content graph, oil content also raw kitchen water very high, but with the treatment, the central environmental standard value has met. This graph shows the increase and removal percentage of filter combination. The removal efficiency has increased first, second, third, and fourth combination respectively. Let's move on to the conclusion of our research. We can conclude that sand and bricks combination is more effective than sand and gravel combination compared to the overall water quality parameters, and kitchen wastewater quality can be improved by low-cost domestic filter for reuse for irrigation purpose. In COD removal, bricks have played a major role, and gravel's oil removal efficiency was higher than the bricks because oil can attach and absorb from gravel surface. And also we can conclude that there is no significant treatment from the cocoa pit, but however, activated charcoal can improve the water qualities. Out of this combination, sand, bricks, cocoa pit, and activated charcoal layer filtering is the best combination. Overall performance of the fourth combination, all the water quality parameters have met the reuse standard for irrigation, and its performance is mentioned here. Also, finally, we can recommend that sand, gravel, and bricks combination is more effective to conduct the experimental run further. And also, kitchen wastewater characteristics should be done in several households and several institutions, and then characteristic value can be generalized for the entire Sri Lanka. An authority should promote and make awareness to reuse the kitchen grey water for irrigation purpose. These are the recommendations, and these are the references used to research success. Thank you.
Thank you very much, Paranagama. It's a very valuable presentation for reusing wastewater. We know that fresh water is very limited. Therefore, for irrigation purpose, we can use that by treated water from the kitchen waste. Therefore, it's very valuable. Now, presentation is open for discussion. You have 5 minutes for discussion.
It is a really nice study to be witnessed. So you have done under your first objective about the characterization. Second one is the design of this domestic level filter. And third one is the removal efficiency. Under the first one, the characterization. So, you know, the odor is a very important part in this kind of wastewater, even in household and kitchen waste. Have you done this odor investigation or any kind of research or any kind of stuff undertaken?
Yes, Paranagam, please answer.
Hello, sir.
Yeah.
So the odor estimation can't be estimated because of the pandemic situation. Hello?
Yeah. So there are, you know, ways to measure that one. Now, one is now you can make this some panelists and all that. You can use the natural nose as well. Now, there are some e-nose and electronic stuff as well. And then second part is you can measure this some component inside, maybe H2S or methane, the chemically also. So why didn't you consider that part?
Yes, sir. I didn't get any chemicals because to make this environment friendly, I only used to local available materials. And I think odor is not much problem because after the experiment, all the materials were washed out with the pure water.
Yeah, simply, you know, when you are doing these characteristics, order, temperature, turbidity, suspended solist, and all these cases are prime importance. And again, now you can read it out after now your further studies. Olfactometers also they are to measure these odors. So if it is all right, you are telling that, but when you are getting this characterization,
Yes.
odor is there because, you know, with this anaerobic digestion and with this wastewater. And the second question, how about this now? Now characterization done by, you know, all around the world. So how have you compare with your data with this existing, you know, Asian and about other you know, regional characters?
Yes, sir. I have characterized and compared the raw kitchen data with the Asian countries' kitchen wastewater data. I mentioned that data comparing in the table. It's someone same.
So any deviations found?
Yes, sir. COD value is very much high in our study.
And then how about your final now? You identify your filtration, you know, system. Is it now, how about after that? Now you done a good research and you came up with a good treatment method. And then what? Then how the way forward?
Please unmute. Others, please.
And how you way forward about that? Now you came up with good set of results, and how you going to, you know, commercialize? So any other way of moving forward?
Yes, sir. Sir, can you repeat the question again?
Now you have done this purification unit you have, okay, you have developed.
Yes. Yes.
So how after that way forward, how you going to, you know, is it any commercialization after from here in future? What are you doing?
Still not commercialized, sir. But in future. Hello.
Yeah.
I think you can patent your invention and you can commercialize it recently. I think even as a department, even our technology transfer office will help you. Okay, thank you very much. Now time is passing for 5 minutes.
Thank
Can we
you.
move to next presentation? The topic of the next presentation is effect of mechanical tools on cinnamon harvesting, presented by SPI Dining. Dining, please.
Yes, madam. Can you hear, madam?
Yes, yes. You can share your presentation.
Okay, madam. Madam, screen share option.
Janid, please share your screen.
Yes, Janid, you can share now. Janid, do you have any problem?
Madam, I can't share this presentation.
Yes, can we move to next until the Janid get ready?
Okay, madam.
Yes, Janid will get ready for maybe next or at the end, right? Now, otherwise
Okay,
time is a problem. Then I'm sorry for that. Then
okay, madam. Okay.
we will move to next presentation. Next presentation on effect of two-wheel tractor operated tillage implement on soil properties in Kilinochchi, Sri Lanka, conducted by Ms. Kirushika.
Good morning, all of you. Today I will present about my final year research. My topic is effects of two-wheel tractor operated tillage implements on soil properties in Kilinochchi, Sri Lanka. These are my outlines of my presentation. Introduction. There are many of issues with Sri Lankan agriculture. High expenditure for agriculture operation, farmers face diseases due to unnecessary chemical usage, environmental degradation, land resource competition, insufficient use of appropriate technology, post-harvest losses, expenditure higher than the productivity. Soil consists microorganisms and macroorganisms. In agriculture, tillage is the most significant and expensive activity. Tillage increases soil productivity, minimize the waste, conserves energy, and reduce the negative impacts to the environment. Proper selection of tractors and equipment for a specific farm minimize the power inputs for crop production. Problem statement. Currently in Sri Lanka, with the exception of few brand new tractors, the majority of agriculture tractors have become obsolete. If we are burning more fuel will end quickly. At the same time, it creates a lot of pollutants. Therefore, comprehensive evaluation of two-wheel tractor performance under various treatment conditions is highly essential. Objectives of my study: to evaluate the performance of two-wheel tractor mounted implement under controlled experimental conditions, to suggest improvements to be incorporated into the tillage operations. These are the materials I conduct my research. Methodology: site selection, soil analysis, testing parameters of the two-wheel tractor, experimental design and field test, general setup of the instrumentation system for evaluating tractor performance, statistic analysis. Site selection: I select the land of Department of Agriculture, Engineering, Faculty of Agriculture, University of Jaffna. Parameters of two-wheel tractor: model RV80 from Vietnam, tractor type 4-cycle 1-cylinder, engine type horizontal, 8 HP horsepower, fuel tank capacity 9.5 liter, compression ratio 18. Rotavator has 14 blades, rotavator length 60 centimeter and blade cutting width 15 centimeter. Parameters of single moldboard plow. Landslide width 3 centimeter, landslide length 3 centimeter, moldboard thickness 6 millimeter, beam length 19 centimeter, cutting width 30 centimeter. Soil parameters analyzed. Soil parameters were analyzed before and after the readment. Particle density, soil particle size distribution, and soil Atterberg limit are analyzed only before the readments. Bulk density, porosity, soil texture, soil moisture content, soil infiltration were analyzed before and after the readments. Soil parameters analyzed method. Bulk density, core sampler method. Particle density, specific gravity method. Soil particle size distribution, seed analyzed method. Atterberg limit, use liquid limit device. Soil texture, class jar test. Soil moisture content, specific method, use moisture tester. Soil infiltration, double ring infiltrometer. Field test and experiment. Same operating condition were maintained in the field treatment. First one is same operated, same gear. Second gear, same fuel. Treatments. There are 3 treatments. Land preparation with rotavator is T1, land preparation with single moldboard plow T2, land preparation with both T3. Tree replication. Total experimental unit experimental design is RCBD. 2-wheel tractor performance were analyzed. Velocity, RPM, wheel slippage, fuel consumption, and overall plowing depth. Results and discussion. Soil parameters before and after analyzed. Tractor performance analyzed. First one is bulk density. Bulk density. It's dependent on mass and volume. After plowing, soil was loosened so that bulk density reduced. You can observe my results of various 3 treatments. Particle density. It was 2.34 gram per centimeter squared. It's depending on the mineral composition of the soil. Porosity. After plowing, the soil became loosened so that pores are increased. You can observe the various treatment porosity in this chart. Soil particle size distribution. Clean gravel less than 5% fines. Well-graded gravel soil gas. Uniformity coefficient Cu greater than 4. Coefficient of curvature 1 between 3. The Atterberg limits were determined based on the moisture content of the soil. Liquid limit 42.5, plastic limit 28.9, plasticity index 10.3. Soil texture. Soil texture no change throughout the experiment. All soil are loamy soil, sand 40%, slit 40%, clay 20%. Soil moisture content. Moisture content important for regulate the soil temperature. Microorganisms require water for their metabolic activities, essential for photosynthesis. It helps for chemical biological activities of the soil. I prepared this graph. You can observe my various treatment moisture content. Soil infiltration. Observation. After plowing, infiltration was increased. The first one graph is T1 treatment and second one is T2 treatment. This is T3 treatment. Infiltration depends on the soil texture, the topography and morphology of the slope, state of the ground surface, and initial condition of the soil turbidity. Velocity. Every plot area is 13 into 5 meters squared. Take a time rotavator less than moldboard. This graph describes the results of various treatment. velocity. T1 velocity higher than T2 velocity. Wheel slip. Wheel slip depend on tractor velocity. This is the equation for wheel slip. Single moldboard plough wheel slip is higher than the rotavator wheel slip. This is the graph. RPM. Bigneo RV18 two-wheel tractor maximum RPM 2400 and continuous RPM 2200. This graph describes RPM of various treatment, and rotavator treatment RPM was higher than the single moldboard RPM. Fuel consumption. You can observe my various treatment fuel consumption. T2 treatment, rotavator fuel consumption less than the single moldboard fuel consumption. Because of single moldboard heavy weight, moldboard has more frictional force between soil surface and moldboard surface. All three treatment, T3 treatment taken high fuel consumption. It was 1.89 liter per hour. Overall flowing depth. Flowing depth is highly important for plant root growth. Single moldboard plough cutting width is higher than the rotavator. These are the overall flowing depth of the my various treatment. SAS analyze RCBD. These are the ANOVA chart. Velocity and wheel slip, fuel consumption and overall flowing depth. P greater than F. SATs analyze for between soil parameters before and after used feed test. Conclusion. Analysis of variance ANOVA of result data revealed significant confusion errors, wheel slip, velocity, fuel consumption, and overall flowing depth. P less than 0.05. In moldboard plough is better flowing than rotavator. It creates highly flowing depth and help to better root growth. Both T3 treatment is create higher overall flowing depth, but it consumes more fuel rather than the other treatment. Most of soil parameters no change during flowing. When flowing, only cloth size of soil parameters were changed. These are the reference of my research, and thank you.
Thank you very much, Kirusika. Actually in northern part of the country, Jaffna, she was conducting this experiment for rural farmers. Because our farmers using the tillage implements, sometimes they use moldboard, sometimes they rotavator, but moldboard for primary, but rotavator for secondary tillage. But people are sometimes without using moldboard, they are using rotavator for all the process, all the tillage operations. That's why she's doing that experiment. Therefore, now the presentation is open for discussion. We have 5 minutes. Hiroshi, may I ask question? Hiroshi, what is your suggestion for people in the Jaffna, farmers in the Jaffna? Which implement you can suggest for doing their land preparation? Because land preparation is that they need more energy. Energy means fuel. They need to combustion of petroleum fuel as diesel. Therefore, what is the more appropriate method for land preparation in Jaffna region?
Yes, ma'am. I prefer in this land, moldboard is better treatment for all preparation because better root growth and overall flowing depth also high, and fuel consumption better than the rotavator. So that I prefer moldboard is better to this land.
That means all land preparation, primary and secondary. Oh, that's okay.
It's primary best.
Is there any more questions?
Can I ask a question?
Yes. Welcome.
So one thing I have to know from your research, usually the rotavator is used for different purpose and plow is used for different purpose. As example, if you use plow, it's turning soil. But if you use rotavator, it's like crushing the soil. So why you check this different? Because these two implements are used for two different activities. So why you compare these things? What is the reason for comparing these two things?
Sir, I only prepare for the land for primary treatment. So I compared both in say I used these three treatments for same land and same condition. So I prefer which is better equipment for better land flowing in primary flowing.
I think Dr. Arivansa is not get proper answer. Just I will give brief background only. Because the Jaffna people actually just after war, they are using the machineries what they available. Sometimes they are using for primary and secondary both one implement because they cannot available other implements to get access for the implements. Therefore, some places they are using moldboard plow for both operations, primary and secondary. Some region people use rotary for both operations. That's why that Jaffna University in the Dr. Kannan Agricultural Engineering Department lecturer, senior lecturer, he want to compare this which one is what is the effect of these using one implement for those both operations like primary and secondary. I think that will be the reason for conduct that experiment.
Okay.
If there are no any more questions, can we move to next presentation? Thank you, Kirushi, for sharing your valuable information.
Thank you, ma'am.
Then next presentation, evaluation of commercial compost enriched with a Pavala rock phosphate and feldspar on growth of tomato, presented by WHANT Vijayasekar.
Good day, everybody. I'm here to present my final year research to undergraduate research symposium on the topic of evaluation commercial compost enriched with the power of phosphate and feldspar growth of tomato. And I discuss my supervisions, internal supervisor Professor S. Vijayatunga and external supervisor Dr. Chantavidran. It's my outlines. Here I'm going to give some brief introduction about my research. You all know inorganic fertilizers give strong increase the productivity and growth and yield of plant community, but the application in inorganic fertilizers not give a good path, but also these are the dangers to like deterioration of the environment. So the new world tend to use organic fertilizer instead of inorganic fertilizer. So between organic fertilizer and municipal waste compost keep big concern because of large quantities of municipal waste. So however, the municipal compost amount NPK is not enough to get maximum output of crops. So overcome this problem, we need to introduce some materials to enrich nutrients. So this research done by enrich phosphorus and potassium using powder phosphate and feldspar. These are my main objective to evaluate the effect of compost enriched with ARP and feldspar on growth of yield of tomato, and determine the change of selected soil properties when using the compost enriched ARP and feldspar. Material methodology. When start the material method, I started where I did my research. It's Faculty of Agriculture, University of Florida, between lecture hall and library. So my experiment were going under the 5 treatment. Treatment 1, normal soil, and treatment soil plus municipal solid compost. Treatment soil plus enriched compost. Treatment 4, soil plus municipal MSW municipal compost plus chemical fertilizer like TSP, MOP, and urea. And treatment 5, finally soil and chemical fertilizer. 7 number of the replications. It is my mixing ratio of the soil and compost. Treatment 1 and treatment 5, 100% soil. Treatment 2 and treatment 4, compost 1:1 ratio. Treatment 3, soil plus enriched compost 1:1 ratio. It is the application chemical fertilizer treatment 4 and treatment 5. You can see here time schedule before plant, 3 weeks after planting, and 6 weeks after planting. You can see amount I did apply to my treatment. Static analyzing. I did use IBM SPS status 25 based on the ANOVA using Dunstan's test. Data collection, these are my parameters: plant and diameter, numbers of leaves, number of flowers, number of fruit per plant, yield, weight per plant, and dry weight per plant, in addition to soil pH and EC. So this is some photographs of my plant growth stages. Yeah, and finally yield of tomato. So result and discussion. I first like to discuss soil analysis. You can see nitrogen 0.18, phosphorus 0.002, potassium 0.26. You can see here only soil is a pure nutrient source. So second is I put in diagram municipal compost and kitchen compost both in same place because easiness of the comparison. You can see enriched compost always show the high nutrient value in PK rather than the municipal compost. So first parameter, plant height, you can see in here all over the period treatment for it means soil compost plus chemical fertilizers higher plant height, and treatment enriched compost shows higher increasement after the 5th week. You can see in 9th week of the plant height. There's no significant difference between treatment 2, treatment 3, and treatment 4, but treatment 1. Number of leaves with times. You can see same as for plant height. It also shows the T4 higher number of the leaves. Let's see 9th week. You can easily comparison in here. Treatment 3 and 4, there is no significant difference, but treatment 2 shows significant difference to the treatment 3 and treatment 4, but treatment 1 and 2 shows there is no significant difference. Palm shoot diameter, it's same as height and leaf number of the leaves. No need to discuss further. So you can see 9th week of the plant shoots. There's no significant difference between treatment 3 and 4 and treatment 1 and 2, but there is significant difference treatment 1 and treatment 3 and treatment 4. So number of the flowers, total number of the flowers treatments, you can see there's no significant different treatment 3 and 4, but there is significant different treatment 2 and 3. So the treatment 1, 2, treatment 5 shows significant difference to treatment 3 and 4. Number of fruit, you all know, all different number of fruit depend on number of fruit. So mostly same results come like number of flowers. There is no significant difference treatment 3 and 4, but treatment 2. So treatment 1 and 2, there's significant difference. fresh weight of the tomato plant. I did calculate fresh weight and dry weighted balls shows same result. So I discuss only dry weight variation. Can see treatment C and treatment 3 and 4. There's no significant difference. Treatment 2 and 3. You can see there is significant difference. Treatment 1 and 2 also showing the significant difference. Finally, total age of the tomato plant is the basic and main part. You can see in whatever the result of there's no significant, but finally yield showing treatment 3 and 4, that's significant different. Some kind of high significant different. And treatment 2 compost plus enriched compost shows significant different. And treatment 1 and 5 shows significant different to the other all treatments. Here is pH change. You can see other than treatment 1, there's no variation of pH value. Other treatment, treatment 1 shows increasement and low decreasement, but finally it's all treatment shows 6.5 to 7.5, between 6.5 to 7.5 pH. When you discuss EC values, the main part, treatment 3 always shows higher EC because of feldspar and rock phosphate is multiple compound. It's release not only potassium and phosphorus and other more than signs. So it shows high EC value always. And first beginning second EC highest value shows soil treatment for soil plus compost plus chemical fertilizer. But finally, you can see in second place in soil plus compost, because compost always release nutrient in a small amount, release with a amount with time. So I just put EC value in here bar chart to get a more understand. So I put some yield result to easiness of my conclusion. So treatment for chemical fertilizer plus beneficial compost showed highest performance. And treatment 3, enriched compost, which means enriched with a power rock phosphate and feldspar, shows growing performance as much as T4. But T4 yield showed 70.2 higher yield comparison the comparing the 3. Rather than treatment 2, treatment 3 showed higher growth yield. So enriched compost can be used as a substitute instead of the medicinal compost. So treatment 3 performance higher than always treatment 2. If we get yield, it's more than 15%. So here my reference. Thank you.
Thank you, Vijay Sekhar. It's very valuable presentation, because now government want to move towards the organic fertilizer, because we have in Nepal area this rock phosphate deposit. Therefore, it's very, very timely important experiment. Thank you, Vijay Sekhar. I mean, the presentation is open for discussion. You have about 5 minutes.
You wanted to enrich the compost, adding the phosphorus without adding this rock phosphate. What is the phosphorus percentage in compost? Without addition of
Vijay Sekhar have some signal issue.
Of the compost, we need as a recommended level 0.5%.
So original compost, what is the amount?
Can I hear me, or is there any problem with my voice?
Okay. Yes, now okay.
Amounts recommended level 0.5%.
What is in the compost? Original compost?
Normally, it depends. If we are using municipal solid waste, it's nearly 0.23. It's depend.
What is your compost?
About the bulk.
What is your compost? Is it municipal solid waste?
Yes, sir.
And now it is said to be now using this phosphorus. Now you are keep adding phosphorus. The pH will get in some acidification. Have you did check the pH during your for this plantation in the soil or the media?
Yes, sir. I don't know. It's a machine also. Whatever, it's some kind of acidic, but within 2 weeks, 3 weeks, it's okay. It's going to be okay with pH value.
So when you're doing the research, the science is the base. Now in that case, it is really there's an antagonistic effect. Now if you add in this, keep adding phosphorus, now acidification, and then it is very clear there are thousands of scientific articles that for ferric and zinc absorption is going down. And again, exchangeable aluminium also due to this acidification. So when you are proposing these cases, might not be a problem for tomato, but other cases it is clearly evident. So have you read those things? You cannot say I don't know those kind of stuff. You have to be, as a scientist, you have to answer the questions. You have to read the literature.
Yes, sir. Absolutely,
because when you are going to do these things, and some cases mention that nodulation also improve in these cases. So those things scientifically proven. So in your case, you have to show that in my phosphorus enriched with this rock phosphate, doesn't matter. pH is in this range. Ferric and zinc stuff is not a problem. Exchangeable aluminium is not a problem. That is what a scientist should do.
Okay, thank you, Professor Jayasinghe. Is there any questions from the Mr. Vijayasekara? If there are no any other questions, can we move to next presentation? Thank you, Mr. Vijayasekara. Next presentation is improving cocoa peat medium for living wall in green in the field by Miss Palagidara. HPUK Palagidara.
Good morning, all of you. Our research topic is improving cocoa peat medium for living wall in green in the building. This is outlines. Firstly, I would like to bring brief explanation of my research. When the population is increasing, rural areas turn into urban areas. Then green areas turn into human-created surfaces. Because of that, heat of the urban areas drastically increased than green areas. This is called heat island effect. Then lost the thermal comfort of urban residents. From establishing green walls help to reduce of the heat island effect. All types of vegetated wall surfaces are called green walls. Green facades and living walls are main type of living wall. In green walls, plants are grown in vertically, and vertical cultivation is very hard because soil can't be used as a potting media due to the high weight. So, lightweight growing media should be used in green walls. Cocoa peat is the most popular growing media in many green wall structures. Here is the reason for using cocoa peat in many green walls. You can see the weight difference between typical soil and cocoa peat. When used cocoa peat instead of soil, gives 91.87% weight reduction. But better potting media should be able to fulfill nutrition requirements of the plants also. Let's move to the problem statement. There are some advantages of cocoa peat: lightweight, high water holding capacity, low cost. But cocoa peat has a major problem. Its nutrient composition is very low. You can see the nutrient difference when comparing with typical biocompost. According to that, the problem can be resolved for using organic biowaste. Let's know the significance of the research is improving the lightweight and fertile potting media from combining cocoa peat with other agricultural bio-waste and testing it an actual greenhouse setup to evaluate the temperature reduction performances. Let's move to the objectives. Improving cocoa peat as lightweight and fertile media for the living world, evaluating the chemical and physical properties of growing media, evaluating the plant performances which are growing in this media, evaluating the temperature as environmental parameter, evaluating aesthetic value of living world. This is methodology that I followed. We selected wall of the new auditorium as a research site. Pitonia and Ohio plants were tested in the research. Experimental setup was prepared by using 60 centimeter rain gutter pieces. Then we prepared growing media. Those are 100% cocoa peat, 1:1 cocoa peat goat manure mixture, and 1:1 cocoa peat compost mixture. After that, growing media were filled to the rain gutters and connected to the wall in wooden frame. After plants were established. Experimental design, which I used for the research, was split plot design. This is a photograph of our living wall setup. Then I did data collection. I checked 3 plant parameters, and those are plant height, plant leaves, and area coverage. Data collection of physical and chemical properties was done using these methods and instruments. We collected temperature data using thermocouple. The measured places are between wall and plants, both Pitonia and Ohio, and control wall. We did aesthetic value data collection using Google questionnaire. I used these software tools for data analysis. Next, move to the results and discussion. Here, evaluated the parameters of plant performances. This graph shows that number of leaves Pitonia and Ohio plants got after 7 weeks according to their potting media. In here, Pitonia and Ohio plants in cocoa compost medium had highest number of leaves. For the better reduction of temperature, the surface of buildings should be covered by plants. So area covered by plants is very important. Overall, Ohio plants covered large area than Pitonia. Among the media, Ohio plant, which in cocoa compost media covered the highest amount. Over the 7 weeks time period, Pitonia plants in cocoa peat compost media was observed the highest type, and Ohio plant in cocoa compost media had shown the highest type. Next, move to the evaluation of chemical and physical properties of growing media. According to the mean values of tree media, the bulk density of all tree media are in the recommended level. According to the t-test, there was a significant difference for cocoa peat and cocoa peat goat manure mixture. With considering about the mean values of tree media in true density, only cocoa peat compost medium was in recommended level. According to the t-test, there was no any significant difference in cocoa compost medium. When considering about the mean values of tree media in porosity, no any media was on the recommended level. According to the t-test, there was no any significant difference for in tree media. According to the mean values of tree media in water holding capacity, cocoa peat and cocoa compost medium were on the range of the recommended level. According to the t-test, there is no any significant difference for water holding capacity in cocoa peat medium. When considering about the mean value of nitrogen content, tree media no any recommended level. According to the t-test, there are cocoa goat and cocoa compost are no any significant difference for nitrogen in tree media. According to the mean values of pH in tree media, cocoa peat and cocoa goat mixture were on the only recommended level. According to the t-test, there is no significant difference in tree media. After expanding physical properties of each media, I would like to show weight comparison of potting media with typical soil. I fill 3 liters of media to each and every rain gutters. We can see the weight of cocoa compost mixture 1092.6 gram, cocoa goat mixture 703.2 gram. But if it is filled with soil, it will be weighted in 4800 gram. Next slide show evaluation of temperature as an environmental parameter. Within 6 weeks and 3 times per day, first 9 a.m., we can see there is a 2.4 Celsius reduction between wall and Ohio plants. Between both plants show low temperature than control wall. Among these two plants, between wall and Rohio plant's temperature is the lowest one. At 12 p.m. and 5 p.m., temperature of Rohio plant is the lowest one than Petunia, but the temperature reduction observed in a different amount. Let's move to the evaluation of aesthetic value. Here, 5 types of aesthetic value preferences were evaluated. Total population was 55 respondents. According to the flowering habit, flowering plants had 75% preference from respondents and 25% respondents for non-flowering plants. In considering about the aesthetic preferences of constructive materials, wooden frame had 49% preferences from respondents. Modified plain gutters had 32% preferences and 90% preferences to the plastic pots. When considering about the plant selection for green wall, ornamental plants had 33% preferences from respondents. Leafy vegetables had 29% preferences. Medicinal plants had 26% preferences and 12% preferences to the vines. In preference of plant selection of the green wall, green color had 52% preferences and 48% preferences were specified. When considering the preferences of Rohio and Petunia plants, Petunia had 77% preferences and 23% preferences had the Rohio plant. Let's move to the conclusion. The plant growth parameters of both Petunia and Rohio plants in cocoa peat compost growing medium show the best performances in plant height and leaf count. Most of the chemical and physical properties match with the standard values for cocoa peat compost medium. Highest leaf cover shown by Rohio plant, which is planted in cocoa peat compost medium. Most light-weighted media was the cocoa peat goat media. There was 85.35% reduction can be seen in cocoa goat media and 77.24% reduction can be seen in cocoa compost media than typical soil. Finally, temperature reduction at 9 a.m. between wall and Rohio can be seen up to 2.4 Celsius. Between wall and Petunia can be seen 2.38 Celsius. Temperature reduction 12 p.m. between wall and Rohio can be seen 3.41 Celsius. Between wall and Petunia can be seen 1.93 Celsius. Temperature reduction at 5 p.m. between wall and Rohio can be seen 2.19 Celsius and between wall and Petunia can be seen 1.16 Celsius. According to the questionnaire survey, around 75% people would like to have flower plants as the plants for the green wall. Wooden frame took the highest preference, around 49% had more aesthetic value as a constructive material. Ornamental plants had 33% of highest preferences considering aesthetic values. In this study, Petunia got 77% preferences as the ornamental plant. As the color, green color had majority preferences around 52%. Those are my references. And thank you.
Thank you very much, Ms. Bhalagedara. It's very timely topic about now Sri Lanka is moving towards green building concept. Therefore, the results of your research will be helpful for having to take some decisions to reduce the temperature, because as a tropical country, it's very important. Now, the presentation is open for discussion. You have 5 minutes.
Thank you very much. I am Champa, Ms. Pahalagedara. Thank you very much for your very nice study and presentation. Actually, now you have done selecting of suitable potting media for vertical gardening. Okay. Did you compare your results with the available literature? What they have found? I think there are many literature in this field these days. So did you compare your results with the literature available? Ms. Pahalagedara?
Yes, Ms. Pahalagedara, please. Ms. Pahalagedara?
I think she is no online.
Oh.
Hello, madam.
Yes, yes, please, please. Can you hear Professor Tampa's question?
May I repeat it?
Yes, Uchita, yes, yes. Did you hear Professor Tampa's question? We cannot hear.
Is she talking?
Yeah, I can just. Yes, her mic is open in the participant list, but cannot hear, no? Kahala gedara, please. Can you hear us?
Yes, madam. Yes.
Yes. Can you hear? Did you hear that Professor Tampa's question?
No, madam.
Yes, please, Professor Tampa, please.
Yeah. What I asked was actually your study is very important study, so no problem. Actually, there are many studies for this vertical gardening and things. Then did you compare your results with the literature available?
No, madam.
Then how it become a research then? You are doing research.
Madam, I compare a cocoa peat, but cocoa goat mixture and cocoa compost mixture.
No, Uchita. She asked about is there any temperature reduction in green wall?
Yes, yes, madam. Yes,
What are the data, the literature on that?
Your results match with the earlier literature results, or you are getting different values?
I'm getting different values. Temperature reduction is literature values have 4 Celsius reduction, but I could get 2.4 Celsius reduction.
Literature shows 4 degrees Celsius reduction.
Yes.
Which plant variety?
Rohio plants.
Same.
And between.
I think we have seen your garden and everything what you have grown, that there are a lot of spaces, no? That may be the reason. Did you get my statement? I think she has some communication with the internet problem. Okay, thank you.
Thank you very much for Tampa, and thank you, Ms. Pahalagedara. Actually, due to some internet disturbances, she may not, maybe we cannot communicate each other. Thank you very much. Then we are moving.
Hello, Ms. Pahalagedara. I'm Jinendra here. Is she connected?
She has some problem.
She cannot do it, Jinendra.
Yes, the time is over now. Do you have any more?
It's okay, then let's go.
Okay, is it okay? Sorry. Because she has some signal issue, even then we can get some 1 or 2 few seconds to clarify some questions new. But unfortunately, the Pahalagedra cannot properly get the questions because of some signal issue. Is it okay, Dr. Jinendra?
Yeah, it's okay. So I just had some, I think, some comment because we are using this cocoa peat because of it has several properties. That one is that it's long-lasting, that it can retain many times, reusing. So with this, adding this compost and biomaterials, probably that it tends to biodegrade instantly within 1 or 2 cycles. So therefore, the maintenance aspect we have to consider. So I think she might have referred literature and all these things. Somehow that's just my comment.
Okay, thank you very much. Thank you very much, Dr. Jinendra. And also Ms. Pahalagedra. And we are moving to next presentation. Natural binders to stabilize neatly invented wall care putty developed with waste sludge. Presented by Ms. Sandareka.
For your all, research topic is natural binders to stabilize newly invented wall care putty developed with waste sludge. Presentation outline. Let's see the brief introduction about the research. Wall care putty is a leveling substance that is the primer material applied before wall painting. Normally, it provides protective and smooth base for the painting. Furthermore, demand of the wall care putty rapidly goes up because of the infrastructure development as well as white cement, acrylic, POP is well-known putty in the market, and talcum, quartzite, gypsum, and cement are the main raw materials of most of the wall care putties. However, people currently think about the greening construction, otherwise sustainable construction. In Sri Lanka, sustainable soil-based wall care putty has been developed from drinking water treatment sludge in Begum drinking water treatment plant. It has been invented by Professor R.U. Halodra and Ms. Himahansigal Kanda. As part of the sustainable construction, another innovative approach is utilizing biopolymers in civil engineering activities. Biopolymers are organic inclusions that occur in nature or are produced from natural processes. These materials have been used as a strength material, binder, stabilizer, and lubricant in construction sector. These are recent studies on biopolymers usage in construction sector. These are widely used biopolymers in construction sector inventions. Let's see the problem statement of this research. As I said earlier, there is a newly invented wall care putty. It was stabilized with cement. We know that cement manufacturing is one of the most major contributor in global warming and climate change. So in this research, biopolymers, in other words, is a natural binder, are going to be used as an alternative stabilizing material instead of the cement. These are my research objectives. First one is to explore the possibility of using natural binders to stabilize newly designed wall care putty made from the alum sludge from Begum drinking water treatment facility. Second one is to determine the best natural binder and mixing ratio for maximum stabilization potential. This is the methodology which I have followed. First phase of the study is the selecting natural binder. As a natural binder, bellfruit extract, Thalkurundu leaf extract, and boonbark extract were selected. The second phase is the designing the mixing design. As a third phase, I conducted the putty application test one by one. First one is the moisture content test. Oven dry standard method was used to determine the moisture content of each putty mixtures. And second one is the observational shrinkage test. Prepared putty mixtures were applied on cement plaster panels and kept to air dry for 24 hours. After 24 hours, visually observe the crack patterns and severity of the cracks. Third one is the fungal growth test. Fungal growth test was conducted according to the ASTM test standard, and environmental chamber also prepared according to the ASTM test guidelines. And prepared samples were introduced to the environmental chamber by a complete randomized block statistical model. Then weekly fungal defacement was visually observed and rated according to the ASTM rating criteria. And let's see the results and discussion of this research. According to the moisture content test results, maximum moisture content was recorded from mix 7, it is bellfruit 90%. Minimum moisture content was recorded from mix 5, it is Thalkurundu 80%. This is the one-way ANOVA analysis for the moisture content data set. According to the ANOVA analysis, p-value of the data set is 0.3546. Since p-value is higher than the 0.05, H0 is not rejected. Therefore, all mean values equal in 5% of the significant level. And this graph shows the average moisture content in each binder mixtures, and this graph shows the moisture content and solid content variation in each putty mixtures. Approximate moisture percentage of the artificial putty before applying to the wall is 66%, but invented putty shows the moisture content variation between only 51% to 56%. Let's see the observational shrinkage test results analysis. And this table shows the bone bark extraction shrinkage test results. And this table shows the Daulkurundu leaves extraction shrinkage test results. And this table shows the bare fruit extraction shrinkage test results. According to the shrinkage test results analysis, this alum sludge powder was well stabilized with selected 3 natural binder, and all samples were tightly adhered to the plaster panels than water treatment plant sludge powder without any binder, and from that first objective was achieved, and as well as approximate drying time of the all putty samples is equal or less than 24 hours. However, some small cracks were this kind of small cracks were observed on sample surface, and so cracks were categorized according to the severity index and surface smoothness. According to that, Daulkurundu 70%, bare fruit 70%, and bone bark 90% present less cracks. And among those, bone bark 90% present less cracked and good smooth surface appearance. And this slight cracks shows due to the different moisture levels and different material constitute in each putty mixtures. Therefore, it presents a different crack pattern and in different severity levels. According to the Gunawardhan et al., commercially available white cement putty have superior performance from bright, smooth, crack resist, and strong adhesiveness. With compared to that, this invented soil-based wall care putty also have good adhesiveness for all samples and smooth appearance for the some samples. And let's see the fungal growth test results analysis. Even though environmental chamber provide optimum condition for the fungal growth, there were no fungal growth observation during the 3 weeks incubation period. According to the studies, food, moisture, optimum temperature, optimum humidity level are necessary conditions to the fungal growth. These samples contain enough food materials but not enough moisture content to grow fungal growth. And according to the ASTM rating criteria, invented putty fungal growth can be rated as 0. Similarly, fungal growth test has been conducted for lime and commercially available putties by Gunawardhan et al. And that result also implies that no fungal growth observation during the incubation period, and it is also rated as 0 in ASTM rating criteria. According to the putty performance analysis test, newly invented soil-based wall care putty present good performance considering these 3 tests, and all samples worked well with 3 natural binders with regard to bonding strength, adhesiveness, and crack resistance, and improving the properties of the by conducting more researches. It has been potential to use as a primer material to wall in construction industry. And together with all tests, second objective was achieved. According to that, best binder is the bone bark extraction, and best binder proportion is bone bark 90%. And these are some strengths and limitations of this research. As its strength, to develop this putty material in massive scale, this natural binder can be chemically synthesized, as well as year by year drinking or treatment such generation is increasing and it is continuing process. Therefore, putty production can be continued. This is eco-friendly soil-based wall care putty type. Therefore, it will be a part of the sustainable construction in future. As a limitation, natural binder extraction were difficult to keep in raw condition without refrigerator. As a summarization of this research, newly invented soil-based wall care putty well stabilized with the selected 3 natural binder and present good adhesiveness, bonding strength, and less cracking, as well as bone bark 9%, sample present best binder performances. In overall, this study will be a new step of the to the sustainable construction in future, since it provides a solution to the environmental impact from cement production and sludge production from the drinking water treatment plant. And these are some future directions of this research: durability analysis, moisture content, moisture absorption analysis of the putty, and degradability analysis, tensile strength and strength, tensile test to measure the bonding strength, and testing more binder proportion, and finally market analysis of the new type of color soil-based wall cap putty. And these are my references, and thank you.
Thank you very much, Ms. Sandareka, for conducting a very valuable research study on green construction. It's very important for sustainable world because we know that for green building concept, we need to have a green construction material. Thank you again. And now the presentation is open for discussion. You have about 5 minutes. May I ask questions, Sandareka?
Yes, madam.
Actually, it's very important to having natural binders because it's very green. Therefore, just I'm asking about what is the availability of this material if we want to adapt to some kind of commercial application. Actually, we need plenty. Is it possible to get that that you decided that boom plant, no?
Madam,
yes.
Yeah, madam, in this experimental stage, the available natural binders can be used to these experiments, to do these experiments. When we commercialize this kind of putty, we want to chemically synthesize these materials by finding most good binder. We want to find the better binder from this, and after that we can chemically synthesize to introduce to the market.
Yes, is it then we can say green? That the product, if you are going to chemically synthesize, we need to have many chemicals. When we consider about the life cycle analysis, it may not much green. Is it possible? Can we say that synthesized material which you extracted from Bhumi plant, is it green?
Madam, did you ask that chemical synthesized materials are green or?
Yes, yes, yes. Now, actually, we want to adapt this kind of green technique, green applications for the putty, making putty as a Bhumitech use as a green material for preparing natural binder.
Yeah.
Then the limitations limitations of the product, then you suggest that synthetic material.
Yeah.
Chemically similar with Bhumitech extract, but Bhumi plant extract. Therefore, I am asking that the synthesized one is green. Then can we use it as a green product for our construction industry?
I think that the chemical synthesizing procedure was somewhat not green, but I think we compared to the existing natural existing binder that called cement materials. I think rather than cement materials, our chemical synthesize that Bhumi or other barefoot materials are okay.
Yes, yes. The barefoot materials and other maybe it may be threat for food security. Maybe people are using that bale is a very good medicinal value plant. Maybe we can adapt to Bhumi. Maybe yes, I agree with you. Maybe that yes, that will be more compared to cement. We can. Okay. Is there any questions or any clarification? Okay. Then if there are no any questions, can we move to next presentation? Thank you very much, Sandareka, for sharing with your valuable findings.
Thank you, madam.
Then next presentation, near infrared spectroscopy for quick detection of agar wood formation in Aclaria Krasna by Mr. Hera.
Hello everyone. Here I'm going to present my research on the topic of near-infrared spectroscopy for detection of agave formation in Aclaria crasna. This research was conducted to meet an industrial need as a request made by Sadahartha Plantations Private Limited. Here's the content of my presentation, and here's the introduction. Agave or Vallapatta is a group of plants belong to family Thymilaceae, and these plants produce extremely rare type of aromatic fragrant resin due to its self-defense mechanism. There are two species very effective and efficient in agave production. Out of them, Gynopsis valla is very famous as Vallapatta in Sri Lanka, and it is endemic to our country. Unfortunately, commercial production of this species banned in 2007. Aclaria crasna is imported to Sri Lanka and commercially cultivated in our lands to produce agave. And in this study also, we use this Aclaria crasna to our research work. And here's the economic significance of the agave. Basically, there are 4 different products. They are agave oil, chips, powder, and value-added products. As you may be excited to note that 1 liter of agave oil trade up to 30 to 50,000 US dollars. When considered about the current exchange rate, it is about 10 million Sri Lankan rupees per 1 liter of agave oil. Agave is a fast-growing tree. Here you can see a 3-year-old Aclaria tree. We can maintain 400 trees in a 1 acre land and gain 6 to 10 million Sri Lankan rupees per acre per year. Basically, the cultural practices of this industry are minimum other than the inoculation and the general fertilization. Although agave industry seems to be extremely profitable, but maintaining the productivity is quite challenging because the current identification is very disruptive. Due to that, it ends up with very little yield with lots of disappointment. If we know it before the harvesting process, we can give induced stress again, or we can give further time to develop agave inside those trees. Therefore, agave industry is suffering from this issue for years. On the other hand, process mechanization is also stagnating without the inside weaving tool. Our process is a labor-intensive and a time-consuming task. In this video clip and also these photographs, you can see that how these workers are doing their task and how this work is labor-intensive. And consider about this work, it is account 20 to 30% from the cost of production. When consider about the cost of production, it is a higher amount for this labor work. And so the NIR tool will make the automation realistic to meet the industrial expectations in near future. Consider about the NIR. NIR is a rapid, non-destructive and chemical-free method that extensively applied into many agricultural and manufacturing industries worldwide. And also there are reports on several wood-based applications as well. However, consider about this industry, there is no report on NIR development for agave identification. Therefore, the main objective of this study is to develop a NIR methodology to identify the agave presence inside the Aclaria crasna. Under that main objective, there are 2 specific objectives. The first one is assess the factors influencing NIR prediction, and the second one is find the best NIR model configuration under the above factors. Here's the methodology. We conducted the experiment both in field as well as the lab conditions. In field conditions, the spectra were taken from randomly selected 28 plants from the Horpavara and Arandini plantations. Then the harvested wood logs, that the samples from both plantations were transported to the Mapalana for our lab experiments. The next step was to prepare the samples. For our first experiment, it is to evaluate the influence of the bark. We made these wood logs with and without bark condition, and we get the spectral data. And our second experiment was to evaluate the influence of the surface roughness. To that, the rough surface were maintained by remaining the handsaw cutting, and the smooth surface were made by using sandpaper finish. Our third experiment was to evaluate the wood thickness effect on the prediction models. So we maintain 1 millimeter to 6 millimeter normal wood thickness up to the agave formation, and we get the spectral data for each normal wood thickness up to the agave chip. So our fourth experiment was conducted in Horpavara and Narandini plantation sites using living plants to evaluate the maturity level and of agave for the prediction. So the one spectral set were taken from the plants spent 7 months after the inoculation, and the another set of spectra were taken from the plants spent 17 months after the inoculation. Here you can see the NIR instrument that we use to this spectral data acquisition. And in this, consider about this instrument, it is capable to taking spectra from 500 nanometer to 1100 nanometer range. And the number of spectra were taken is given in this table for each and every experiment that we are conducted in this research work. Data analysis were performed using Pirouette software, and the classification and the prediction of sample groups were done by using SIMCA discriminate analysis. Consider about this SIMCA. SIMCA is a multivariate classification tool based on the principal component analysis. Here is the SIMCA data table and the model configuration settings. The various model parameters such as mass transformation, number of factors are to be optimized for better prediction. Here you can see the results and the discussion part. For our first experiment, here you can see the results. The highest interclass distance came with this first derivative mass transformation, and it is for the bark removed samples. In this scatter plot diagrams, you can see that the best separation for this class, consider about this bark removed and the bark present samples, the agar present and the absent samples very clearly separate in this bark removed samples. And also, when we consider this bark present samples, here you can see the sample log, one of the sample log that we tested in this experiment. You can see these lichens and other different kind of variations are available in this wood log. So these variations badly affect on this sample testing. So the class separation is not very perfect when considered about this bark present samples. And here you can see the prediction rates. Overall, highest prediction rates came with bark removed samples for this experiment. And here is the second experiment, influence of the surface roughness. Consider about the results. The highest interclass distance came with these smooth samples compared to the coarse samples. Prediction rates are also the same. The highest prediction rates came with these smooth samples that we maintain in this experiment. And for our third experiment, assess the influence of the wood thickness for agar prediction. Here you can see the highest interclass distance came with this without any pre-processing method. That means for this raw spectral data, get the highest interclass distance for each and every wood thickness, that means normal wood thickness up to the agar formation that we consider in this experiment. And the best sample group separation was observed at the 3 millimeter wood thickness. You can we can compare these values with this other normal wood thickness that we maintain up to the agar formation. And for the prediction rates, 2 millimeter to 5 millimeter, that means 2 millimeter to 5 millimeter wood thickness up to the agar formation get the highest prediction rates comparing to 1 millimeter and the 6 millimeter wood thickness. Consider about this overall prediction rates. And for assess the influence of the maturity stage, the agar present samples get the highest prediction rate for the mature samples. That means matured agar samples. It is when consider about that results, we get that results from the second derivative mass transformation with the mean center pre-processing method. And here you can see the 975 nanometer wavelength is the best and the most effective wavelength for detection agar inside this Aclaria crasna trunk by this NIR method. And here are the conclusions. The bark removing event improved the prediction results from 85% to 97%, and the surface smooth improved the prediction from the 90% to 95%, and the optimum wood thickness between the NIR sensor and the agar wood chip was 3 millimeter, and the prediction was better with mature agar wood samples than the rest. However, the both mature levels performed over 33% of average accuracy for prediction. And consider about the wavelength, it is 975 nanometers more effective for the future machine learning development. Consider about this discriminating power. Consider about this outcomes of this research work. We can avoid the previous mentioned current identification and the issues. That means the destructive identification can be avoided by using this resource. And here are the recommendations for the future machinery development. When you consider about that machine, it should be with a bark removing event, and also the cutting tool should be fine cutting tool, and we have to maintain 3 millimeter normal wood thickness up to the about formation to when we are considered about extracting this wood chip, and 975 nanometer wavelength is best for the machine line development. And here are the references that I used to use in this research work. And thank you very much.
Thank you very much, Mr. Akila. It's very valuable finding. Actually, agave is one of the important, most possible plants for getting have more export value, because at the moment Sri Lanka is in the lack of some foreign currencies. Therefore, we still have a very good future for having. Even I believe that you are the one of inventor in our department. Therefore, you may next step of your research study may be develop of that the fine machine for having this processing of agave product, and even without damaging the plants, with using that NIR we can do that. Identify that the agave is ready for harvest, right? Therefore, thank you for doing that. And this presentation is now open for discussion for 5 minutes. Please ask any questions or clarification from Akila or Mr. Herat.
Hello, Akila. Jinendra here.
Yes, sir.
Yes. So I saw that you saw that your presentation, there are so many different methods for inducing agave, and those are different. They are inducing different physiological status inside the plants. And now, then how will be your consistency of your results for detecting agave formation by differently induced methods? Now you have checked it by the agave induced by nailing method. How will be the consistency of your results for other methods, the agave induced by other methods?
You mean, sir, that the identification stuff now?
Yeah, yes.
Okay, sir. So normally that there are many methods that at this time in Sri Lanka is doing this traditional method. We know that we have to destruct the plant, and there are many other things like MIT, like magnetic induction tomography and sonic tomography, and there are many research under the wood-based about this CT, that means computed tomography also. So sir, that NIR method is a promising one, because that sonic tomography is normally using in Indonesia, Thailand like countries. But the issue is it takes many time, and we don't have a portable device for that, and also it's a very time consuming method, and it's getting just like a graph, like a histogram.
My question is that now let's say that in the nailing method you will induce hollow inside the plant, right?
Yes, sir.
But chemical method you will not have that, right? No, there is no hollow created inside the plant. So therefore, that the results obtained from that nailing method will be consistent with the other method. What do you think?
That means the inducing
results presently we obtain will be similarly work with the agave formed by other methods.
Yes, sir. Yes, sir. It can be because of that. Normally, the nailing method to induce this stuff is kind of a low quality agave performing inside the agave trunk. That means the Aclaria crasna trunk. So now they are not using that method in current situation. But for other, that mean for total, that mean all tree agave method, that means kind of a method using that chemical method, those are also the same kind of results can be get by this normal method. So that by using this NIR also we can get this all the results, that means that we can observe that the trunk inside the trunk without any destructing for each and every method that they are using in this industry to induce this agave, sir.
Okay, thank you.
Thank you, sir.
Thank you. Mr. Herat, is there any questions you have about 1 minute?
Yes, I have just one clarification. I want to know that your invention now are being used by the company, or what is the progress of your research now?
So actually, in this study, we have to we actually for the machine development, we identified the main recommendations. By that, we have to combine with another company. We have to combine this AI technology to machine development stuff, because that the current the normal method that we are using in this research, the sensor is very cost, because that it is around 35 lakhs. But in consider about the combining with AI, that means artificial intelligence and this deep sorting stuff to this NIR spectroscopy, and we can produce a low cost sensor for with less that means the higher bandwidth and the higher less range nanometer range. So because by that we can produce that machine eye. Then we have to consider about the extracting stuff like a CNC machine stuff. Then these by going this recommendation, it is possible if we have the correct sensor to get the real-time data set.
The company they are working on that?
Yes, of course.
Okay, thank you.
Yes, Sakila. Actually, we can do some collaboration with University of Ruhuna, with Tsukuba University, even Professor Noguchi today, our keynote speaker is interesting on the artificial intelligence event, right? We have better future to collaborate, start some research with discussing the internal supervisor, Dr. Ginny. Okay, then thank you very much, Mr. Herat. Now we are moving to the next presentation. The performance evaluation of four-wheel tractor using biodiesel derived from coconut oil by Mr. Jayaratna.
I am here to present our research findings on performance evaluation of four-wheel tractor using biodiesel derived from the coconut oil. This is the content of this presentation. Day by day, global energy consumption is increasing with growing population and unsuitable energy consumption. Agriculture sector play a major role in the energy consumption and mostly use the diesel engines. As we know, the adverse effect on non-renewable diesel combustion on human, environmental and social health system. In this study, put forward biodiesel as a viable alternative fuel for the diesel engines. Biodiesel is a renewable and sustainable fuel derived from the vegetable oil and animal fat. Biodiesel produced by trans-esterification process. We can use both animal and plant oil sources for the biodiesel production. We can use tallow as an animal oil source and jatropha, rapeseed, sunflower oil, palm oil and coconut oil we can use as a plant oil source for the biodiesel production. Reduction of the atmospheric carbon dioxide, decreased carbon monoxide, hydrocarbon and particulate matter emission, sulfur content zero are the major advantages of the biodiesel production. High production cost, limited feedstock availability and high fuel specific consumption are major disadvantages of the biodiesel production. In this experimental study, focus on the performance of four-wheel tractor operated by biodiesel extracted from the coconut oil, from escaped coconut waste and from market. Coconut is native to tropical eastern region. Sandy saline soil with abundant sunlight and regular rainfall favorable for the coconut cultivation. Fuel demand increasing day by day because of the limited fossil fuel resources. Burning fossil fuel is mainly contribute to the carbon dioxide emission. Greenhouse gas emission adversely affect to the changes in rainfall pattern and frequency of extreme weather events. Biomass fuel has potential to reduce atmospheric carbon dioxide. Biodiesel is being promoted worldwide as a supplement and alternative automotive fuel for the mineral diesel. The prime objective of this study to produce biodiesel from coconut oil from market and extracted from escaped coconut waste. Then test the properties of coconut methyl ester from both sources, and finally evaluate the performance of oil tractor driven by biodiesel and compare it with the mineral diesel. When looking into the methodology, biodiesel produced by the base catalyst trans-esterification process. Firstly, preheated coconut oil placed with the methanol and sodium hydroxide using magnetic stir. This mixture continuously stirred 2 hours. Then transfer into the separation funnel. Separation time is 3 to 4 hours. After the 3 to 4 hours, upper layer contained coconut methyl ester and lower layer contained glycerol and impurities. After the glycerin is separated, coconut methyl ester carefully transferred to the clean container. For the washing coconut methyl ester, 50% volume of the distilled water from oil added into the coconut methyl ester and left it 3 to 4 hours for the settling down. Then, after the settle down, coconut methyl ester transferred to the clean container. In the properties evaluation of the biodiesel, density, kinematic viscosity, higher heating value, flash point, and pH value test under the standard methodology mentioned in this table. To compare the mean value, Tukey test was used. In this slide, show the preliminary test with coconut methyl ester at Brown's company. We used TAPE 45DI tractor for the test. It has three-cylinder and direct injection type engine. In the field performance evaluation, effective field capacity, theoretical field capacity, and field efficiency tests were performed. When looking into the result, we get 485.78 milliliter of the coconut oil from the 1 kilogram of well-dried scrap coconut waste, which is substantially a good amount. Total coconut methyl production is 13.6 liter. We get 850 milliliter of the coconut methyl ester harvest from 1 liter of the coconut oil. When considering specific gravity, there is no significant difference in specific gravity of biodiesel produced from scrap coconut waste and market available coconut oil. When considering viscosity, there is a significant difference among the mineral diesel and coconut methyl ester from scrap coconut waste and market available coconut oil. When considering kinematic viscosity, coconut methyl ester shows a higher kinematic viscosity values, but both coconut methyl esters fulfill the ASTM standards. Also in the flash point, coconut methyl ester have achieved the ASTM limits. Comparatively, biodiesel shows the higher flash point than mineral diesel. Mineral diesel has higher calorific value than biodiesel. Among the biodiesel, coconut methyl ester from the market available coconut oil has highest energy content than coconut methyl ester from scrap coconut waste. When considering pH values, there is a significant difference between among the mineral diesel and coconut methyl ester from scrap coconut waste and coconut methyl ester from the market available coconut oil. Before the field performance evaluation, we test the soil in the selected area for the using for the field performance evaluation. These are the results we observed in the soil physical property testings. When considering the field efficiency and fuel consumption, there is no significant difference between the tractor running with the mineral diesel and coconut methyl ester. In this study concluded biodiesel as the best alternative for mineral diesel, considering it fulfilled the ASTM standard. In this research, we received contribution from the Brown's Agriculture. These are the references. This is the end of this presentation, and thank you for your cooperation.
Thank you, Mr. Jayaratne. The presentation, actually, biodiesel is one of the most green fuel if we can adapt with waste material, especially if we can focus to coconut waste, refuse waste. Every day to day, our home, we have that coconut waste growing, and if we can collect procedurally, systematically, and drying and the producing biodiesel, it's more valuable as a green application, especially for fuel, alternative for the fossil fuel. And the presentation is open for discussion. Now we have about 5 minutes. May I ask questions? Mr. Jayaratne, is it possible?
Yes, madam.
Is it possible to adapt this technology for our rural level two-wheel tractor operation for land preparation or some machinery application?
Yes, madam. We can establish a center for the collect scrap coconut waste, and this using this center, we can extract the coconut oil, and this coconut oil we can use for the biodiesel production.
What did you think about the cost of collecting, extraction, those things? Is it the technology is available or not?
When compared to the mineral diesel, the price of the biodiesel somewhat higher, and if we can use for the scrap waste, we can reduce the cost of production because of the when using scrap coconut waste for the extract 1 kilogram of the using 1 kilogram of the scrap well-dried scrap coconut waste, only 20 or 30 rupees for the 1 kilogram.
Okay. Is there any question from the Mr. Jayaratne?
So now it is, for this biodiesel, so there are some vegetable oils and some animal fats, and most of the cases now there are a lot of research going on. So why you tell that coconut oil is as a raw material is better than, what are the advantages using that compared to other kind of vegetable oils?
When considering Sri Lanka, coconut are the mostly available source for in the to produce biodiesel in the Sri Lanka, and also we can use palm oil, but in the government regulations we cannot use palm oil because of the government limited to use palm oil.
So have you read about now? It is said to be that when it comes to this coconut, coconut scrape or whatever you name it, and it contain. How about it is the fatty acids? Is it medium chain or the percentage is in high? So are there that kind of advantages in coconut oil?
Sorry, sir? I cannot clear your question, sir.
Yeah, what is the fatty acids in the coconut oil compared to other vegetables or the animal fats? Composition of the coconut oils, fatty acids.
Yes, sir. To check that fatty acid content, that test was too much cost is too much high, sir. Then
How about the literature says?
Literature says there are the in the literature, it's a fatty acid composition. The fatty acid compositions are the difference because of the that change with the number of the carbon in that chain, and
that is
that
what I'm asking.
that
The medium chain, long chain, short chain.
Yes, sir.
So in coconut oil, which kind of is it medium chain? So it is said to be it is having 70% or 60%. I don't know the number. The medium chain fatty acid is high.
Yes, sir.
Yeah, that is what when you are doing this kind of fun, you have to read things and you have to then get aware about what have been done, and then analyze the gap and then proceed. So otherwise, no, we are not the experts. So you are the expert. And again, what are the main problems in using biodiesel? Now we've been now we can witness that there are a lot of research going on, everybody doing, and a whole lot of the papers coming up. So why it is not popularized yet? Why? What is the main
Because of
problem
the
as a researcher? Why?
To compare with the mineral diesel, biodiesel production cost is somewhat higher, and other difficulty is most of the time when like USA like country, they mostly use the sunflower seeds or rapeseed oil for the biodiesel production. That is not ethical because of the we in the there are some standard for the we cannot use for the edible sources for the biodiesel production.
And how about now? It is now when you are converting this the vegetable oil, can you 100% convert? Is it the process is complete or incompletion or any kind of things there?
Yes, sir. We can not 100%, sir, because of the when separation procedure somewhat are going to with the glycerin, and if we can use for the more effective method for the separation, we can use get more high percentage for the biodiesel as a biodiesel.
Apart from glycerin, what are the traces you can find or some chemical forms?
Sorry, sir.
Apart from this glycerin, so what kind of traces or some chemicals can be found in this biodiesel? Have you checked that one or any other literature support?
No. In the biodiesel productions, mostly in the production we use sodium hydroxide or something like base, and that due to this base that pH value is somewhat higher in the biodiesel. Then we use distilled water for the purification process. Then that some extra base can contain with the glycerins.
And how about this damage to the fuel filters or these pipelines? Have you checked with this one with compared to the mineral stuff in your produced oil?
Yeah, no. In that we not check in this research, but we can for it for the future.
Yes, Professor Jayasinghe, the time is over now. Yes, okay. Then actually, Jayaraj, those are some of the challenges of biodiesel, because even I believe that we have to make some logistic arrangements. People like to go, not like to collect the things and preparing extraction oil and doing the transesterification, but they like to go to the shed and fill their tanks to do any kind of preparation. Therefore, we need to have some kind of, like European countries, we need to have some logistic arrangements to move it to from the production place to the I think the distribution phase, like kind of in future, I think within 5-10 years, we can see some B20 or B80 in our petrol shed also, right? Okay, then thank you very much, Mr. Jairam and also Coach Jaisingh, to enhance, to raise this type of real application of the biodiesel into the our country. Thank you. And then now we are moving to next presentation. Develop University Industry Partnership Model for Agro-Industry Innovation, Sri Lankan and European Experience. Presented by Samaravira.
I'm Kasar Samaravira. Our research is develop University Industry Partnership Model for Agro-Industry Innovation, Sri Lankan and European Experiences. This is the content. I'll give a brief introduction. We all know what is agro-industry. They produce goods and services related to agriculture. These agriculture industries face many kinds of disturbances from economic, environmental, and social aspects. However, agricultural sector has contributed 7% to Sri Lanka's gross domestic production in 2020. We can increase this contribution by improving agriculture innovation in Sri Lanka. The University Industry Partnership is a critical component for this innovation process. We can define it as a contractual relationship between the universities and the industries, having specified joint rights and responsibilities. It brings advantages to universities and industries as well. When considering university-industry collaboration models, there were some historical innovation models. They are linear model of innovation from 1945, non-linear model of innovation from 1980. It has highlighted the feedback mechanism, and the triple helix model. This is the most important concept. It has highlighted the importance of interactions among universities, industries, and government. In here, we have given some evidence of university-industry partnerships in other countries like UK, China, and Australia. In Sri Lankan context, although there were some collaborative activities, the government has started to support university-industry collaboration from 2005. But according to the previous studies, collaborative industry-based research activities are still limited in Sri Lankan universities. Problem statement: compared to the international best practices, there is no formal and straightforward mechanism to develop university-industry partnership in Sri Lanka. The Sri Lankan government has highlighted the need for innovation to improve the productivity of agricultural industry. This study attempts to bridge this gap by formulating a model to develop university-industry partnership for agro-industry innovation in Sri Lanka by obtaining European good experiences. Our general objective is to develop a model to improve university-industry partnership for agro-industry innovation. Specific objectives are to identify current status of UI partnership for agro-industry innovation, to identify and propose communication methods to bridge industries and universities to innovate real-time solutions for problematic areas of industries, and to obtain European good practices to formulate a model for UI partnership in agro-industry innovation. This is the methodology. It includes a questionnaire survey, data collection, data analysis, discussion, and literature review. For the questionnaire survey, the target population was academics from Sri Lankan state universities, especially from agriculture faculties, and industry representatives from agriculture industry. Sample: 30 academics from universities and 60 industry representatives from industries were selected using purposive sampling method. Data collection was done by using two different questionnaires for universities and industries, mainly through the Google Forms. These are the variables and measurements that we used. All the measurements were qualitative measurements. Data analysis was done by using descriptive statistical tools and Wilcoxon sign blank test. We conducted a discussion with professors from UK to obtain their good experiences in university industry collaborations to develop our model. Also, we have conducted a literature review by using research publications, websites, journals, and reports to identify previous studies in university industry collaborations and in order to achieve the other objectives. Results and discussion. Under the current status, universities and industries have given varying percentages for participation for the collaborative activities in agri-industry innovation. This disparity may be caused by more academic awareness and maybe the cultural differences.
Previous studies also have highlighted the importance of adapting each other's cultures in order to participate more effectively in collaborative activities. According to our findings, here we can see both universities and industries involved in industrial placements for graduates and undergraduates in a higher level. But according to the literature, the best university-industry partnerships are research partnership for innovation process. According to academic perspective, the existing policies within the country are not sufficient to strengthen the university-industry collaboration. Although there were some policies like tax incentives and research grants in other countries, there are more policies to encourage university-industry partnerships than us. The OECD report also provides 21 policy instruments to promote university-industry partnerships. They were categorized as financial, regulatory, and soft instruments. Here we have given some of them. This is also a recent concept, policy interconnection. When developing university business collaboration policy, all the other policies are interlinked together. We have identified video conferencing, websites, and social media tools as good communication methods to bridge universities and industries. Many good practices are used in European countries to promote university-industry partnerships. Knowledge Transfer Partnership, KTP, is one of them. In UK, it is a government-funded program. Normally, it involves three parties, university, company, and a KTP associate. Innovation vouchers. Their innovation vouchers are also similar to KTP, but actually it's a smaller version of KTP. In UK, it's a partly government-funded program. Innovation agencies. In Sweden, there is a rating system for higher education institutes. Depending on that rating system, they receive different proportion of funding for research and development activities. Intersectoral mobility in France and tax incentives for research, joint research and development in Iceland are also good practices to promote university-industry partnerships. Business incubators, they help startup companies and individual entrepreneurs to develop their businesses. In Sri Lanka, we also have several business incubators here. This is also a good practice to promote university-industry collaborations. National Science Foundation of Sri Lanka and National Research Council of Sri Lanka also support for the research and development activities for innovation process. According to previous studies, although there were many collaborative activities, the most of them are conducted through the personal contacts. Therefore, we should try to develop a formal method. This is the existing mechanism of university-industry collaboration in Sri Lanka. Normally, Technology Transfer Office, so UBSs conduct collaborative activities between universities and industries, but actually there is no proper leadership to encourage them. To overcome these problems, we suggest this Sri Lankan University Industry Partnership model. In here, universities, industries, and government, this is the triple helix, they are interconnected through this University Industry Collaboration Council. This is the most important part of this model. It has responsibility to coordinate these collaborative activities. Actually, it is the main communication center among these three parties. It can govern by UGC. Then government should provide good policies to encourage university-industry partnerships, like research grants and more tax incentives for university-industry collaboration. Then industries can come up with the industrial problems to University Industry Collaboration Council, then council can deliver them to universities. According to their capacity to resolve those problems, universities can join for the collaborative activities. After signing the working agreement, universities and industries can continue their projects alone. According to the purpose, they can categorize as consultancy, research and development innovation, technology transfer, and product commercialization. Here we have given the above mentioned things in detail. Finally, our aim is to develop a model to improve university-industry collaboration in agro-industry innovation in Sri Lanka. Therefore, we can apply the above given model to agricultural sector. That means we can apply agriculture industries and agricultural faculties here. Then it will increase the agriculture innovation in Sri Lanka. These are some supportive literature for develop our model. Conclusion, according to the study, the current status of university-industry partnership in agro-industry innovation was not in a satisfactory level. websites, social media network, and video conferencing were identified as good communication methods to bridge industries and universities to innovate real-time solutions for problematic areas of industry. Finally, we proposed the Sri Lankan University Industry Partnership model to improve university industry partnership for agri-industry innovation in Sri Lanka by obtaining European experiences. These are the references, and thank you.
Thank you very much, Ms. Samaraveera, for your valuable findings and with the presentation. Actually, as a country, I think we have to move these partnerships, university industry partnerships. At the moment, there are research on one side and the industries are other side. Therefore, it's very important to have such the collaboration. In future, then we can develop you as an agricultural country. There are many industries. There are many high potential to develop agro-industries with using the research findings from the university. Therefore, the findings, research findings in the book can be moved towards the real world applications, right? Therefore, it's very, very important. Now, your presentation is open for discussion. We have about 5 minutes.
Now, this is really important now. A lot of research doing by the university and as well as industry, and we have the society, right? And therefore, as you know, the evaluation parameters say collaboration. So number of projects, university and the industry, or number of research papers, number of patents, and again, knowledge sharing in between the publication and meetings, networkings, and the mobility, employability, and continuation of education, putting this industry into the university lifelong learning and the intellectual property rights, right? And then, as I mentioned, the culture, collaboration, value, competitiveness, exchange. So how now? Now there are a lot of models everywhere now. You can do a research and you can implement and you can draw this one. And how these things implementing. So how, as a researcher doing 6 months and reading a lot of systematic literature review and getting international exposure about, you mentioned that you did consult some professors in EU context. And how are you going to say now, give a very quick workout for the Faculty of Agriculture, University of Ruhuna?
So I have taken some literature for develop this model. Also, when joining for the discussion with professors from UK, I have got their experiences in KTPs and other consultancies. I have used several models from there are some Malaysian models, and in UK there is a Verbix model, and I use these models to develop this university industry collaboration model.
So I'm just asking now, now it is okay, very nice and very, it is okay when you're looking at it, it's all right. But why it is not kick-starting? So what are the major barriers and how you going to address that one? And what is what is the specialty of your model?
In the existing model, there is no proper leadership. So therefore, we propose this university industry collaboration model, university industry collaboration council to overcome these barriers. It can the main problem is, according to the literature, main problem is the communication among these three parties. Therefore, this council can work as a main communication center.
Right now you've done it and you have written your thesis, and it is how you take it to the university administration or the UGC. What's the next step?
I have mentioned there, Minister of Agriculture also highlighted their need for this agriculture innovation to improve the agriculture productivity. Therefore, we can propose this model to Minister of Agriculture, and then it can be open the path for to contact the government. Then we can organize a meeting like this in this pandemic situation, we can organize a video conferencing to contact university representatives, industries, and government. Then we can do a brainstorming sessions like and taking their ideas to develop this more. And then when implementing this model, we can develop through according to their ideas. And
now we have our UBL and we have our TTO, right? Those are the existing stuff.
Yes.
So now anyway, you have to get involved with these already existing stuff and then move forward. So how
Yes,
you going to approach this TTO, UBL?
So actually, with this pandemic situation, I was unable to meet the TTO office. I have unable to visit the TTO office, but I hope to visit and talk with them about this approach.
Don't you think you have done a grave mistake? So without consulting them and without doing that, you are doing by your own at your home, and then ultimately you are going and meeting with, they will ask, why didn't you contact me?
So I have taken their data through the questionnaire from the Dr. Dr. Lahiru Prabhada from TTO office. I have taken their data about this university industry collaborations.
When will you have a meeting with this TTO to present your results?
I did. Sorry.
When will you are going to have a meeting with this Lahiru to present your model? When?
So next month I will.
Okay. I am the coordinator of the department coordinator of the TTO office. I will arrange.
Okay, take it there. Otherwise, useless. Yeah.
Actually, recently there are new developments. One of our invention by Professor Alvis and team, and then we are going to commercialize it with the help of some famous industry available in Sri Lanka. Okay, thank you very much, Ms. Samaraveera, and also Professor Jayasinghe to having such a wonderful discussion. And next, we are moving to the next topic, use of thiocyanate-based ionic liquid electrolyte in supercapacitors, conducted by Ms. Niranjala Gustinyamadugi.
I'm Niranjala Gustinyamadugi. It's my chance to present our research on use of thiocyanate-based ionic liquid electrolyte in supercapacitors, and it was done with the collaboration of National Institute of Fundamental Studies, Kandy. This presentation will flow on this way. Modern transport, communication, and industrial needs behind the luxury living styles demand high density, efficient, and reliable environmental-friendly energy stocking solutions. Supercapacitors can store electric energy and react to charging and return cycles super fast compared to other solutions. The most common commercial electrolyte used in supercapacitors are organic solvents containing a salt. These solvents generally limit their applications above 70 Celsius degrees due to the risk of cell rupture. It also have a very low flash point, about 10 Celsius degrees, and emits toxic cyanates and noxious gases as combustion products. The use of ionic liquids therefore opened up supercapacitor experiments, and my goal to investigate the performance of carbon-based supercapacitor with triethyl ammonium hydrothiocyanate as electrolyte. Our problem statement is here, and our objectives are to investigate the ability to prepare supercapacitor with THT and test the performance parameters, to optimize the testing sample with few characteristics, and to compare THT capacitor with testing aqueous, gel polymer, and organic electrolytes. In this testing device, activated carbon is the activated material and polyvinyl pyridine is the binder. THT is using as the electrolyte. The current collectors is titanium plates with 2 mm thickness. For electrode preparation, initially activated carbon powder and binder to 9:1 ratio will mix in mortar. Afterwards, the mixture was added into a beaker containing isopropanol and styrene for 5 minutes. After that, the slurry used directly for the preparation of coating on titanium current collectors by spray coating. Finally, electrode dried at 200 Celsius degrees for 4 to 5 minutes in an air recirculating oven. For electrode preparation, you follow these steps and we mention reaction here. Preparation of dichloromethane gives triethylamine hydrothiocyanate as a colorless liquid clear, and finally it gives THT after further process. The next part is optimization, and to optimize the binder percentage, the composition of PVP was varied by the addition different amount of PVP to 0.25 gram of activated charcoal. Here all electrodes were sintered at 300 Celsius degrees for 20 minutes, and the thickness of the electrode layer was maintained in the same manner. To optimization in sintering temperature, by keeping the thickness and PVP amount constant, the sintering temperature was very different temperature between 100 Celsius to 350 Celsius for 20 minutes, and performance of the cell was recorded order to the optimization in sintering temperature. Here, 0.05 grams of PVP was used with 0.5 activated charcoal to make electrode spraying solution. In here, for characterization, we used few technologies, and first one is CV curve. It was obtained by using Metroham Autolab potential stat galvanostat instrument, and it used to calculate the specific capacitance of a supercapacitor. SEM images are used to get morphological characterization of sample surface. PXRD patterns are non-destructive technique that provides detailed information about the crystallographic structure, chemical composition, and physical properties of material. And this gives the crystallized size of the activated charcoal. In here, it shows the fabricated device and its working. Then now it's the discussion and results part. It will go on this way. In the first optimization, non-binder percentage is recorded as highest 26.35 farad per gram at 5% of binder percentage. According to the above results, specific capacitance of supercapacitor is depending on amount of the binder in the electrode activated material. In sintering temperature, the highest was 34.89 farad per gram at 200 Celsius degrees. In this optimization, it shows the specific capacitance of the supercapacitor with THT electrode was significantly affected by sintering temperature of the electrode. In here, we have the comparison among ideal CV curve and the obtained CV curve from fabricated THT device, and the recorded specific capacitance calculated here. This figure shows different magnification levels of the SEM images of activated charcoal. In here, the white particles and porous can be seen. These are porous and layers structure which gives the ability to store charge in supercapacitor electrodes. PXRD patterns corresponding in the obtained activated charcoal samples show white peaks and noise due to the highly amorphous state of charcoal. By having no other diffraction peaks, in indication that there were no impurities present in the prepared activated charcoal sample. With this comparison, we achieved our third objective, and the green bar shows two organic electrolytes. Black shows aqueous electrolyte, purple ones are for green gel polymer electrolyte, and the blue and especially red THT bar shows ionic liquid electrolytes. According to that, THT perform well among other existing electrolytes. When we move to our conclusions, this shell shows 34.89 farad per gram maximum specific capacitance with 20 millivolt per second scanning rate under 1 volt. And in optimization, the best bind percentage is 5% from the activated charcoal amount, and best sintering temperature recorded as 200 Celsius degrees. According to that research, we observed that THT cells also have remarkable performance among other variations too. There are many people seen behind this project, and then it is the time to thank for all these people. These are our references. I'm going to wind up my presentation and thank you for all kind attention.
Okay, thank you very much, Ms. Niranjala. Actually, it's very valuable findings. We can apply the maybe future requirement of the supercapacitor. Now, your presentation is open for discussion. We have about 5 minutes.
So, Niranjala, how about the present situation of this this type of cell, this new technology? What's
Sorry, sir.
What sort of application practically now in? I know that few countries are using these tools, these cells for their various type of activities. How about the present situation?
Yes, sir. The modern solar cell researchers try to compare, create a combined unit with supercapacitor and solar cells. The present situation is itself.
Practical application or the target probable applications. What are those probable applications?
So in this ionic liquid electrolyte supercapacitor, still not using practical applications. Those are in under research level still now.
So what are the other substrate that you can use that, because this is activate carbon? Can we use graphite or some other type of substrate?
Yes, some supercapacitors using graphene-based activated materials.
Okay, thank you.
Yeah, thank you.
Okay, well, Niranjala, what is the next step of your research? What your research team is hope to going to application, going to adapt to some application, your thiocyanate-based ionic liquid electrolyte?
Yes, there is some modifications should add to this, and we have developed this cell further process.
Okay, thank you very much.
Thank you.
Yeah, any questions from the audience? If not, now we are going to conclude this technical session. Actually, when consider about all the presentation from the beginning, actually there are many findings are there. Actually, I believe that we can do some very valuable presentation for the application. Even our keynote speaker also very nicely interpret that how to facing challenges. Actually, all are doing the research related to address some challenges, some issues here. Therefore, after getting this research, we need to fine tune further to apply it for our real world application. Then definitely we have very fruitful future if we can move with that university industry collaborations and biofuels and the supercapacitor technique and also green building applications, some concepts and also some filters for reusing water and even just some kind of energy studies related to land preparation and the things. Therefore, some kind of near infrared techniques application, those are everything are comparatively very innovative, and also we can already we identify the challenges and try to find the solution. Now, next step, we want to develop some real world application. And I hope that our products, so our undergraduates, our graduates now they are graduates, our graduates produce. They definitely they are ready to. They are the distribute their fragrance among the globe, right? Therefore, I wish you all the best for having very good future, for doing something for towards the sustainability of the world. And now we are going to conclude the technical session. Thank you very much for all to supporting to success of this event. Thank you.
Thank you very much, madam, for leading the ship successfully. It is with the immense contribution of many, today's event has been made possible, and they truly deserve a sincere appreciation. On behalf of the organizing committee, I am extending a really hearty vote of thanks. First of all, we would like to extend our sincere gratitude to the keynote speaker of the session, Professor Noguchi Raiso, Professor, Faculty of Life and Environmental Sciences, University of Tsukuba, Japan, for accepting our invitation and sharing your valuable thoughts on agricultural mechanization and biomass utilization on extending to new horizons. Our special thanks to Senior Professor S.D. Vannirachi, Dean, Faculty of Agriculture, University of Ruhuna, for your inspiring words and for being supportive to us in all possible means. Also, we convey our sincere appreciation to Professor S. Vijayatunga, Coordinator, URSAE 2021, for his active involvement and untiring efforts to make this event a resounding success. Next, we would like to say a big thank you to the chairperson of the session, Mrs. C.P. Rupasinghe, Senior Lecturer, Department of Agricultural Engineering, Faculty of Agriculture, University of Ruhuna, for leading the technical session successfully. We are very grateful to the Senior Professor Champa Navaratna, Editor-in-Chief of URSAE 2021, and other editorial board members for their enormous contribution in preparing an impressive and informative proceedings. We must mention our deep sense of appreciation to Professor Jeeva Jayasinghe, Head, Department of Agricultural Engineering, Faculty of Agriculture, University of Ruhuna. Sir, we are overwhelmed with your tremendous contribution in all possible means. Thank you for being the catalyst that stimulates us to do the best and standing as the pillar of our strength. Next, we would like to thank all the department staff members. We have been fortunate enough to be backed by a team of very proactive and dedicated members. Our sincere thanks to our budding young scientists for making this session highly interesting with their competitive, excellent presentations. Further, extending our kind regards to all the participants for adding colors to this event. Once again, thank you all for your contributions in numerous ways in making this event a very productive one. Ladies and gentlemen, we have arrived at the conclusion of the first session of URSAE 2021. The session will conclude with a national anthem. Please honor the anthem by staying silent.
Lanka.
you very much for joining us today. It has remained a pronounced pleasure. We will meet you all tomorrow on the second session of URSAE 2021 on Emerging Environmental Technologies, with a keynote speech being delivered by Dr. B.V.R. Punyavartana, Principal Scientist in Agroclimatology, Natural Resources Management Center, Department of Agriculture, Peradeniya, Sri Lanka. Hope you had a fruitful day with the first session of URSAE 2021. Goodbye.
Thank you, Kirtana.
Thank you, madam.